Let's go over some of the prerequisites that you need to have coming into this course. This is an Angular course. This course is focused on Angular HTTP. So the assumption is that you already know Angular, you've probably used it, and you just want to improve your knowledge on the HTTP communication that is built into Angular. So you need to understand Angular. And the second technology you need to understand is TypeScript. So again, the assumption here will be that you know TypeScript because Angular uses TypeScript. So understanding of TypeScript and Angular, you need to have background in those two technologies. Now, another thing I want to point out is that saying that you need to have some TypeScript background also implies that you need to understand JavaScript because TypeScript is more like a wrapper around JavaScript. So if you know TypeScript, I'm assuming that you also know JavaScript. And then you need to understand HTTP because this is the protocol that is used over the internet, and that's the protocol that we're going to be using to make requests. Now, I'm not expecting you to have any in-depth knowledge of the HTTP protocol, but as long as you understand what requests and response and headers and things like that, as long as you understand what those are, then you should be good to go. We're going to cover a lot of this in this course as well, but just so you know what to expect coming into this course. And then lastly, you need to understand API, which is Application Programming Interface. So this whole idea of having a front end and a back end application, where the front end application is making HTTP call to the back end, those back ends, they're usually called API or Application Programming Interface. So make sure you understand what that is and how it's used in this world today, because a lot of the applications running today on the internet, they're running using APIs. So make sure you understand these coming into this course. Environment setup for this course is going to be fairly simple since we'll be working in the front end. So I'll be using Visual Studio Code as my text editor, but you can use whatever editor you like. You don't have to use Visual Studio Code, but I'm going to be using Visual Studio Code. And then I'm going to be using Google Chrome. So we're going to need to access the developer tools, and I'm going to be using Google Chrome to do that. So if you want to use Firefox or any other browser, feel free to do that. I'm just showing you guys what I'm going to be using. And then you're going to need a terminal. And this is because we're going to be running the Angular CLI commands in the terminal. So you guys will need to have some sort of a terminal. Now, I didn't even have to put this on there. Most computers nowadays, they come with a terminal. But I'm going to show you how you can get one for Windows where you can run Linux commands into Windows. So this is the setup you need. Most of you guys probably already have all of these already, but let me go ahead and show you where you can get those if you don't have them. So to get Visual Studio Code, you just have to go to code.visualstudio.com, and then you can download it for your operating system. As you can see, they support Mac, Windows, and Linux. So just go here and then download it for your operating system. Pretty simple, just go through the prompts and then you should be good to go. And then for Chrome, you just have to go to google.com/Chrome, and then you can just download it using this button right here, or you can just click on this button here. And it's gonna be fairly simple, just accept the license and click OK, OK, continue, and then have it install. Now for Windows users, so I'm using this CMDR as my emulator or terminal. So the reason that I like this when I'm on my Windows computer is because I can run Linux commands. So if you go to cmdr.net, if you scroll down, you should see these two buttons here where you can download it on your Windows computer. And the download is going to be fairly simple. Again, accept the license, click OK, continue, and then boom, it's installed. Now, I'm going to show you what it looks like. I'm using my Windows computer. So it's going to look like this after you have installed it. And you can see that I can type ls, and then I have the list of all everything that I have in this folder. So you can run Linux commands as well, like you can use SSH and many other Linux commands. I don't think you can use all Linux commands for this, but most of them will work in this emulator. So that's why I like to use it when I'm on my Windows computer. But when we start working on this, when we start developing the applications and writing some code, I'm gonna switch to my Linux computer because I like to use it better for development. So make sure you get those if you want to follow exactly along with what I'm doing. Otherwise, you can use the command line, or if you're on a Mac, you can use whatever terminal you want. You can use any editor you want, and you don't necessarily have to use Chrome, but I'm just showing you guys what I'm gonna be using. I want to quickly talk about Angular a little bit. I know you guys are probably familiar with Angular because you're taking this course about the HTTP aspect of Angular, but I still want to talk a little bit about what Angular is. So Angular is a JavaScript framework, and you can use it to design your application and develop your application. You use it to build client-side single-page application. Angular was designed and created by Google. It's one of the most powerful and one of the most popular JavaScript frameworks out there, and I like to use it. I use it pretty much every day, and I like it a lot. Now, that doesn't mean that there aren't any other frameworks or library that you can use. The ReactJS is also very, very popular. And even I am using React sometimes when I'm working on certain projects. So it really comes down to what I need, what I think will work best for the situation. And then I decide if I want to use React, or if I want to use Angular, or if I want to use Vue, or even jQuery, or just plain old JavaScript. So I know a lot of people like to compare, frameworks out there and libraries and stuff. But in the real world, when you need to build an application, it will come down to what exactly you need to build, how you need to build it. You have to take into consideration like security, scalability, and so many other things. And after you've reviewed everything, or all the requirements for your app, then that's when you're going to make the decision if you want to go with Angular, or if you want to go with ReactJS, or if you want to go with some other framework like Vue or something else. So in this course, we're going to be looking at the HTTP aspect of the Angular framework. And that's one of the most important features for this framework, because most client-side applications need to manipulate data. And this data is usually hosted on some server somewhere, and you need to use HTTP to make requests to access this data. Let's quickly take a look at the HTTP protocol. Now, HTTP is the protocol that you use every time you try to access resource from a server. Now, it's not the only protocol that you can use to access a server, but it's the most common, and it's the one that the internet or the World Wide Web uses. So that makes it very, very powerful and very popular. Now, the whole thing with HTTP is that when you have a front-end application, you need to fetch resources, as you can see here, from a web server so that you can manipulate this data in the front end for your client side or client facing application. So that's why these front end applications, or this front end JavaScript frameworks such as Angular or React, they use HTTP to fetch resources, and the resource can be anything. It can be HTML documents, it can be videos, it can be even styles, it can be anything. So HTTP is widely used. You use it every day when you access the internet, either on your phone or your computer. And that's the protocol that these applications, that's the protocol that they're using under the hood. Now we can talk way more about HTTP, but this course is not about HTTP itself. It's how we can use Angular and HTTP to fetch resources from servers. But it's also important to understand what it is, which is a protocol, amongst others, that is used to fetch data from a web server or some server somewhere on the internet or somewhere else on a network. Another very important concept that we have to understand is the concept of RESTful Web Service. Now, there's really two parts to this. There's the REST or RESTful, and then there's the web service. Now, REST is really an acronym for representational state transfer. Now, you can think of this just as an architecture that your application can follow. They have certain rules that you have to follow if you want your application or your web service to implement this RESTful or to be RESTful, and then implement this architecture. Now, the second part to this, which is the web service, is that if your web service implements this RESTful architecture, then your web service becomes a RESTful web service. Now, as you can see, most APIs or application programming interface, which is what the front-end applications usually use, they're using this RESTful or representational state transfer architecture so that they can create their application. So we can talk a lot more about REST itself or RESTful web service. But what I really want you to understand is that once we have our front-end application and we're making HTTP requests, we're making HTTP requests to web services. And those web services, most of them, they're using this REST standard, or they're implementing this representational state transfer architecture. And this is really the de facto standard for building web services nowadays. Maybe something else is gonna come, and we don't know. But for right now, that's the most powerful and the most lightweight, scalable, maintainable way for building these web services that we want to interact with other web services on the internet. So that's why our Angular application or any front-end application they can make an HTTP request to those applications and then get data from them, because they're using this representational state transfer architecture that is a very, again, highly scalable, maintainable, and it's very commonly used for API or web-based application. So earlier I mentioned that we're gonna be using HTTP to make calls to web servers, and those servers, they use this RESTful web service or this RESTful architecture. So maybe this doesn't make a lot of sense right now, but I'm gonna show you how this RESTful web services, I'm gonna show you how it connects to HTTP call that our Angular application will be making. Whenever you have a web service, you want to be able to modify the data on the web service, or read the data, or create data, or delete data. Now, we refer to this as CRUD or CRUD, which stands for create, read, update, delete. And if you think about it, most of the times, or if not all the time, whenever you're using certain applications, you're usually doing one of those operations. So if we take a quick Facebook example, right? So let's say you're on Facebook. If you're on Facebook and you're just scrolling, you're just looking at what people are talking about, and you're just scrolling and scrolling, you're really reading data. So you're doing the R here in this acronym. Now, if you want to make a post, or you're gonna make a comment on something, or you're gonna send a message to one of your friends, then you're creating data. So in this acronym, you're doing the C, which is like create data. And if you made a post, then you realize you made a mistake or you have a typo, then you go in and you click on edit, and then to edit the data, then you're doing the U in here, which is the update the data. And if you don't like the post, you want to post something else, or you didn't mean to post it and you delete it, then you're deleting the data. And if you think about it, really, most of the times when you're interacting with an application, you're doing one or many of those four operations. So the C is for create, the R is for read or to get data, and then we have the U for update, and then the D for delete. And you can see how this is gonna connect with HTTP to create this entire web service architecture that we're talking about. So the C is for create, and whenever you need to create data on the server, you're gonna send a post request. So they associate the create data or create resource on the server with a post request. So the server or the RESTful API or the RESTful web service, they're able to understand that when you try to communicate with them using the HTTP protocol, and you send the post method with the HTTP protocol, then they understand that your intention is to create resource on that specific server. And the same goes for read. So for reading data, you send a get request. So you're getting information or you're getting resource. So when you send the get request, the server understands, or the web service understands, that you're trying to read data. You're not trying to create or update data or delete data. And then for update, you send a put or a patch request. And I'm going to talk about the difference between put and patch later. When you need to update data on the server, you send a put or a patch request, and then the server is able to understand that you're trying to update the data. And then to delete the data, you send a delete request, which is a valid HTTP method or HTTP verb. So you would send an HTTP delete request, and the server will be able to understand that you're trying to delete a resource on the server. So you can see how with RESTful Web Service and CRUD Operations, we can connect that with HTTP so that we can communicate with the server in a way that the server understands. Let's take a quick look at the HTTP communication with Angular. The HTTP communication is how Angular communicates with backend services using the HTTP protocol. So let's take a look at this and see how this all happens. So you will have your client application, and that client application in our case is going to be the Angular application. So this is your client facing or client side application. So that's the application that your users see. That's the application that they interact with. And then you will have your server. So your server will be your backend web service or your backend web services. That's where all these services are. And somehow you want this backend to be able to communicate with this front end. Notice that the backend can be built using any technology. It can be Python, Java, Node, or a PHP or anything else. Now, what you want to happen is you want your client application, in our case, our Angular application, we want that application to be able to communicate with this backend application to manipulate data or to create, update, read, and delete data. And that communication is going to be done over HTTP. So whenever the client application needs to manipulate data, it will send something called a request over to the server. And the server will take that request, process it, and then send a response back to the client. And then you have this client-server communication where the client sends requests over to the server, and then the server sends response back to the client. And this is how the communication happens with the client-server communication over HTTP. Now you have to understand that this is just an overview. There is way more that goes into this. But for now, all you have to understand is that the client application using the HTTP protocol will send an HTTP request to manipulate data. So to create data, we'll send a post. To read data, that's going to be a get. To delete data, it's going to be a delete. And to update, it's going to be a put or a patch. And the server is just going to respond with an HTTP response, and then it will send it back to the client. So I hope that makes sense. And we're going to learn how to do all of this in this course. So to configure our application so that our application can start making HTTP requests, we need to do some configuration. So in the main module of our application, in that case, that's going to be our app module, since we only have one module, we're going to have to import the HTTP client module. As you can see here, we're importing that from the Angular/common/HTTP. And this HTTP client module is a service module that is provided by Angular, and it allows us to perform HTTP requests. And once we have the import, you can see down below, we have to add it in our ng modules so that we can let our application know that we're going to be using this HTTP client module. So let's go ahead and give this a try. Let's go ahead and create our Angular application. And for this, I'm going to be using the Angular CLI. So let me open my terminal, and I've already navigated to the folder where I want to create that application, and that's in my downloads. And I'm just going to go and do ng new, and I'm going to call the application Angular HTTP and press enter. Yes. Routing, I'm going to say yes for now. I'm going to be using CSS for my styling, and that's going to go ahead and create the application. So I'll pause the video and I'll come back when this is done. All right, the download is finished. So I'm going to go ahead and cd into that folder. So Angular HTTP. And I'm going to clear the screen, and I'm going to do code that so that I can open this folder with Visual Studio Code. Okay, here we go. So this is a basic Angular application with all the default. I'm pretty sure you guys know how to do this already. We're going to start looking at configuring this application so that we can use HTTP and start making requests. Let's go into the app folder, and we're going to navigate to the app module.cs file. So this is the main module of our application. And then in here, we need to import the HTTP client module. So I'm going to collapse this, and then right down below this ng module, I'm going to do import. I want to import this from Angular common/HTTP. And what I want to import is the HTTP client module. So I'm going to do HTTP client module. So once we have this imported, we have to pass it into the ng module. So down below here, I'm going to go into the imports array here. I'm just going to go ahead and paste that. So now we have imported the HTTP client module into this ng module, which is the main module of our application. You can think of module like the context of the application, like the space in which the application lives. So now this application is aware of us wanting to use the HTTP client module or the HTTP client to make HTTP call. And that's exactly what we're going to be doing. Before we can actually start making requests, there is another important concept that we have to understand with Angular, and that's the Angular services. So when you build an Angular application, your application is going to have multiple different components. So you can have a user component, and you might have like a profile component. And that's just the way that the architecture of Angular is. You build your UI using multiple different components, and you just make those components work together. Now, let's say you want to fetch data from your backend API or your backend web service so that you can display this data in your component. Now, you're not going to have every single component in your application making HTTP requests. What Angular comes up with is this idea of creating a service. So you have that one space where you have your services, and every component that needs a specific information can reach to a specific service to get this information. So in this example that I'm showing you right now, we have a user component, and let's just assume that this component is displaying information about like a list of users. And then we have another component, that's the profile component, where we're showing information about one specific user. So you can see those two components, even though there are two separate components, they're requesting information about users. So we can create one service. In that case, we're going to call it our user service. And inside that service, we can have maybe two functions. One to return the list of all the users for the user component, and then another one for the profile of one specific user. So that way your code is more organized and you're not using every single component to make HTTP requests, because you have one service that's making the request and every component can reach to that specific service if they need that specific data from that service. So what we're going to be doing in our application, we're going to create a service, and then inside that service, we're going to start writing our code to make HTTP calls. My assumption is that you're probably familiar with the Angular CLI, and that's the same command line that I'm going to be using to create the service that I need. So I'm going to scroll down and we're going to scroll to the command overview, and you can see all the different commands that you can run with the Angular CLI. And the one that I'm looking for is this generate here. And you use this generate to create stuff like to create component, create services, create classes. So I'm going to go ahead and click on this generate here. It's going to take me to a more detailed page of this command. And what I want to do is to use this service here. So this generate service, let's click on that. And you can see to generate a service, you can do ng generate and then service. You pass in the name of the service with some options if you want to. Or you can just do ngg and then service and then pass in the name of the service. So I'm going to copy the shortcut command, so the second one, and I'm going to open my terminal. And then I'm just going to go ahead and paste this command. And now I need to give my service a name. What I also like to do when I'm using services with Angular, I like to put all my services inside a folder. And to do this, I'm just going to pass in a new folder. So I'm going to do service. So what Angular is going to do is, or what the Angular CLI is going to do, it's going to place that user service that I'm going to create inside this service folder. And I'm just going to call it user. And Angular is going to take care of adding the .service.ts. So let's go ahead and run this command. I'll say yes on that. And you can see that the Angular CLI created two files for us, the user service.spec.ts and then the user service.ts. So this is how you create a service in Angular, and we're going to take a look at what this service looks like in the code. So I'm back in VS Code, and what I want to do is go to this file explorer here, and you can see that we have this new folder service, and I'm going to go ahead and expand that, and you can see we have our two files, and the files that I'm interested in is the user.service.cs file. Now the spec file is a test file, and we're not going to be doing any testing in this course. But the TS file, the user service TS file, is the file that we're interested in. So let's go ahead and click on that. And you can see that the Angular CLI stubbed out the class for us, putting in the injectable and provide that service in the root of our application, which means this service is going to be provided in the main module of our application, which is the app module that we have. Now, what we need to do is to inject this HTTP client so that we can start making HTTP requests to a backend service. Now we need to inject the HTTP client in our service. And in our case, we have a user service. And the assumption here is that this user service is going to be manipulating data relating to user or users. So the first thing we have to do is to import the HTTP client. So we have to add an import statement in our class so that we can import this HTTP client. And as you can see, it's coming from the same library. So at Angular common/HTTP, that's the same library as the HTTP client module. And then once we have that, we need to inject it in the class. And the way we do this is by passing a private parameter into the constructor in the class. So as you can see, we pass in this private HTTP and we give it a type of the HTTP client that we just imported. What we're really doing is passing in this HTTP as a member of the class. So as a member of the user service class. And what that means is that we'll be able to use this HTTP anywhere in the class by using the this keyword to refer to it, since once we inject it that way, it becomes a member of the user service class. And that's just how you do dependency injection in Angular. So let's go ahead and give this a try. So I'm back in VS Code, and what I want to do is to add in the import for the HTTP client. So I'm going to go below the injectable, and then I'm going to do import. And then here, I want to import the HTTP client. So I'm going to do HTTP client. And this is coming from the same module. So we're going to do from, and then pass in Angular common, and then /HTTP. So now that we've imported this, we have to inject it into this class. And to do this, we just have to pass in a private field to the constructor. So I'm going to do private, and I'm just going to call it HTTP. You can give it any name you want. The only thing is you have to make sure that the type is of type HTTP client. So I'm going to do HTTP client. which is what we just imported. So now this HTTP is available in this user service class, and we can use it anywhere in the class by just using the this keyword to refer to it as a member of the class. So once we start building our function to make HTTP requests, you're going to see how we're going to be using this as a member of the class by using the this keyword so that we can make our request to the backend. Now that we have injected the HTTP client in our user service, we can make use of it in that service so that we can make HTTP requests. And there are a few ways that you can make HTTP requests inside of the service in Angular, but I'm going to show you one of the most common ways to make those requests. So you typically see a function, and inside that function, you return the HTTP call that you're making to the API. As you can see here, our function name is defined. In that case, that's get users, and it doesn't take any parameters. But notice one interesting thing is the return type. And in this case, that's the observable. Now, we're going to talk a little bit more about observable, but for now, what you need to understand is that observable here means that this code is going to resolve at a later point in time because we're making a network call and we want to be notified whenever we get some data back. In that case, that would be the HTTP response from the server. And that can be the data that we requested, or we can get an error from the server. And then on the second line, we call the HTTP. Remember, we define it in the constructor, which makes it a member of the class. So we're using the this keyword to access it. And then on that HTTP, we access the get because we're trying to make a get request. And this HTTP also contains the post, put, patch, and delete, and a couple more. But in that case, since we're trying to retrieve data, we're calling the get, and then we're passing in the type that we're expecting to get from this API here. In our case, api.com/users. So this API, http://api.com, it's going to return an array of users or a list of users. So the same way we're telling the observable that we're expecting an array of users, we have to tell the get, which is also generic, the type of data that it's supposed to receive from that call. And what the HTTP client is going to do is it's going to deserialize this data whenever this data is resolved or whenever we get the response. And then it's going to parse it as an array of users. Another example of this is if we're trying to get one user. So in that case, we can define another function, which we're going to call get user. It doesn't take any parameter. And the return type is also an observable because this code is not going to resolve immediately. It's going to take some time because we have to make a network call. And then the return type, or in the body of the response, we're expecting to get a user. And you can see we're doing the same thing on the second line. When we call the get, we pass in the type of data, and then we pass in the URL where we think this data lives on that web service. So this is the typical, most common way that you would see the HTTP client being used on an Angular service. And later in this course, I'm going to show you a more advanced way that you can do this. And there's really no right or wrong. It's just a matter of what your requirements are. So sometimes you might have an application and it's so complex, you might have to go with the basic way. But sometimes your application might not be so complex, and then you can use a more fancy, a more advanced way to do this. So for now, let's go ahead and give this method a try. I'm going to be using the JSON placeholder, and if you go to jsonplaceholder.tpcode.com, you should land on this page. And as it says here, you can see that it's a free fake API for testing and prototyping, and it's really free. You can just use it to test your application. And if we scroll down a little bit, and you can see here how to try it. So you see the main URL is the actual website itself. So that's the base URL. And then they have a number of resources that you can interact with. So if I scroll down a little bit, you can see that you can get posts, comments, album, photos, to-dos, and users. So we're going to be using the last one, which is the users. And there's really plenty free APIs online that you can use to test your application, but I'm just going to be using this one for now. So back in our user service, I'm going to go down the constructor, and then I'm going to define our first function. In that case, it's the get users. And remember, it doesn't take any parameter, and it returns an observable of user array. So now we're going to pass user array. Now, we haven't defined this user type yet, and later we're going to define an interface to represent the type of data that we're requesting. But for now, let's go ahead and finish the function. So here I'm going to call the HTTP. So I'm going to do return this HTTP, and then I'm going to call the get on it. As you can see here, we have the delete, get, head, JSON options, and we're going to look at those later. And then we also have the put. So for now, we're going to use the get request because we're trying to make a request to some API to retrieve data. And then we have to pass in the URL where this data lives. And this is going to be the JSON placeholder. So here I can just pass in the URL for JSON placeholder, and then that's going to go to /users. So this is our first function, and don't forget to pass in the type as well for the get. So here we're going to pass in the type, and then let's go ahead and define our second function. So I'm going to copy the first one, go down a little bit, and this is supposed to be get users, and this is get user. This is going to return one user, and I'm going to remove the bracket and pass in the ID here. Let's say in this case, we're going to pass in 1. So now what we need to do is to define this user here so that we can map this data properly. You can see that we're getting errors here in those functions because TypeScript doesn't know where to get this user from. So now what we have to do is to go to JSON placeholder and see if we can understand exactly what are the properties that exist on this user so that we can map that user into this class here. So a good use of interfaces is to just use them to define a type of a specific object. So let's go back to JSON placeholder and let's scroll down to the user, because that's what we're interested in. So here's the user resource. I'm just gonna open this in a new tab just so I can see the response. So here's the list of all the users, and you can see one user here from line 5 to line 27. And the user has an ID, name, username, email, an address, which is an object, as you can see here. And this object contains another object. In this case, that's the geolocation, as you can see here. It's nested inside of the address, which is also an object for the user. And then we have a phone, website, and a company, which is also an object, as you can see, that's defined here. So we need to map this data in our HTTP call so that we can deserialize it properly so that we can have intelligence whenever we get this data back. So what I like to do is to use this website here called transform.tools, and you can specify what language you want to transform to and from. So here, I'm just gonna copy this first user here, which defines the type of the user. And I'm just gonna go back here and I'm gonna remove this, and then I'm gonna paste it. And if you look to the right, you can see that it defines all of the type for us and also the subtype, and it defines the user. In that case, it's setting it at root, but we can change that. And then it passes in the address and the company, and inside of the address, we have the geolocation, and the geolocation is also defined below. So we can define all of those interfaces so that we can create our user service. Now, we don't have to define it that way. We can use the type keyword in TypeScript to define types. And we can also use open and close curly braces and define the type of a data using an object literal. But I'm just gonna go with this approach in this situation. So what I also want you to see is the Angular CLI. You can use it to generate interface. As you can see here, you can just pass in ng generate interface, and then you pass in the name of the interface. So I'm going to use this command, and I'm just going to go ahead and copy it, and then I'm going to open my terminal. So make sure you are inside of your application. As you can see here, I am inside of my application, and I'm just going to paste this command. Oops, I didn't mean to do that. I'm going to copy this again, open my terminal, and I'm going to delete this, paste this command, and I want to put all of those interfaces inside of an interface folder. So I'm going to pass interface and then /user and press enter. So now I have this user interface, and also we need to define the other interfaces. So let's go back so that I can see what I'm doing here. So I'm going to shrink this a little bit. So we have to define the user. In that case, that was the root, and then the address. So I'm going to run this one more time for address. And I'm also going to do it for geo. I'm going to remove this geo. And I need to do it one more time for company. And I'm going to run that. All right, so now I have all my interfaces. So let's go back to the application. And let's expand this panel. And here's the interface folder. And I can extend it. You can see we have all of our classes in here. So what I can do is just copy the information that I got into those classes. So the first one is going to be the root. So let's go back to JSON. Let's see if we can put those side by side. So I have both of my windows side by side, and I'm just going to go ahead and copy everything over. So I'm just going to copy all of this and then paste it in for user. And I like to have the semicolon, so I'm going to put those in. And I'm gonna do the same for the address. So I'm gonna copy everything here and go back here to the address and paste everything here. And I have to do the same for the geo. So I'm gonna open the geo, copy everything for geo, paste it in there. And I need to do the last one, which is the company. So I'm gonna copy everything here and paste it in the company. Again, I like to have the semicolon, but it's not required. I'm gonna close that and do the same here, close this. Now I have to import this, so I can just use the quick fix to import it. And I'm gonna expand this because we don't need this anymore. Now I can go to users and import those classes or those interfaces. So I'm gonna import this from the address and import the company as well. All right, so now our user is defined. So this is the shape of our user. So all we have to do now is to import that user in this class, and we can use the quick fix to do that. Quick fix, import. So at this point, we're ready to go ahead and test those functions. Before we can go ahead and use those functions, it's very important that you understand the idea of observable and subscribers and subscription. So you can see that those functions, they're returning an observable of users. And to illustrate this idea, I created an example and I'm going to walk you through it so that I can explain this to you so that you really understand what's going on here. So I'm going to navigate to the app component and right here. So in this app component, which is just a class with some fancy decorator, and the constructor, I added some code so that I can explain the idea of observable. So I created this type here on line 13, which is just a simple type. I assigned it to an object literal where I define the type of data that our subscription or observable is going to be emitting. So I created a new observable. As you can see here, I'm passing in the new keyword and an observable, and I pass in the type of data that this observable is going to be emitting. Remember, you use observable when you need to emit a stream of data or just some data. It doesn't have to be necessarily a stream. And it's asynchronous, which means it's not code blocking, or it's not going to block the code and wait until the observable is resolved. And in our case, that would be the HTTP request that we're making. So that means that whenever we call those functions in the service, they will not block the code until the request comes back. That's what the asynchronous means. It means that even if the code is not resolved or the observable is not resolved, it's not gonna block the execution of the code. What it's gonna do is it's gonna create a subscriber. As you can see here, we're creating a subscriber that's emitting information or data. And then every time the subscriber emits a data, in our case, once we get a response back from the server, then anyone who is subscribed to this observable will be notified with that data. So you can see I'm creating this observable here. And if I scroll up a little bit, and you can see it's coming from reactive extensions of JavaScript or RxJS. And if I go back to the user service, and you can see this observable here that this is returning, it's coming from the same packet. So observable is going to emit information or data, right? So this is the observable. I create the observable. I say, hey, this observable is going to return HTTP response, which is simply an object with a code that's a number and data that is a string. And then I pass in this callback function, which is the subscriber, and that's the subscriber that's going to emit. Now you have to understand this subscriber is not this subscriber here that's happening here. Okay, so whenever we say subscriber, we're saying that whatever we're going to subscribe to, they're the subscriber. So we're going to be subscribing to this observable here, and that's the subscriber that's sending the data every time, as you can see here. And then we're subscribing to the subscriber. So every time this subscriber up here emits this data, as you can see here on those 3 lines, then this guy who is subscribed to this subscriber will be notified with the data. Okay, so what's happening here is once I create the observable, I say, hey, log this information and then send this data. So whoever is subscribed to this subscriber will receive this data first, and then this next data, and then this other one. So you can think of this as a stream, like we're sending one and then we send another. And then I make the code or this subscriber wait for 3 seconds. And then I send another one, and then I complete the observable. Now this is pretty simple, right? An observable is gonna emit data, and we create it using the new observable. There are many other ways that you can create this. And then I say, hey, emit this data, emit this data, emit this data and then emit this error, but we're gonna comment this for now because when you send an error, then the whole thing just shut down, so it gets completed. So we don't want to do that yet, but I'm gonna show you how this error is gonna come into play here in a second. So we're gonna emit these three pieces of data. In our case, those are HTTP response, and this is just a dummy HTTP response. And then once we emit these three HTTP responses, we're gonna wait for 3 seconds, and then we're gonna emit another one, and then we're gonna complete the stream here. As you can see on the subscriber, I'm calling the complete. Okay, so this is the observable. This is what can be observed by someone. So now we're someone, right? Let's assume that we're someone. We want to be notified whenever this data is emitted. Okay, so what we're gonna do is on this observable that we created, you can see here, this is all the observable, all of this is here. We're gonna subscribe to it, which means we're gonna subscribe to it so that we can get notification whenever there is something happen here, either an error or a next to send the data, or if it's complete. And those are the 3 callbacks that you get with an observable. So you get the next, you call next whenever you need to send the next data or the next piece of data. You call error whenever you need to send an error. In that case, we're not gonna send the error just yet. And then here, I'm just setting a timer so that I can send the next HTTP response after 3 seconds. And then after that, I'm just gonna complete the stream, which is gonna stop everything saying that we're done. And down below in our subscription, we can also listen to those 3 different types of event, right? So that's gonna be the next for whenever a new data or the next function up here is called. So whenever this function is called, this is gonna fire because we're observing this observable, right? We're like someone who is interested in this observable, which is why we subscribe to it. So whenever they emit a piece of data, this function is going to be called with the data. As you can see here, we're passing the data here. So the data is being also passed in here. And we know it's going to be an HTTP response. So we typed it because we're using TypeScript. We can give this a type. And then if there's an error, we're going to get the data. In that case, it's going to be any type. And then we're going to console the error. And then once the complete is called, then we're gonna say, okay, we're done. This observable is no longer sending or emitting data for now. The other important thing is if there is no one who subscribed to this observable, this code will never run. And that's the biggest thing that I want you to understand in this. So if I go ahead and open the terminal, and I'm gonna go ahead and run the application, right? So this is an Angular application. I can just do ng serve, okay? And we're gonna just run the application. We're gonna let that come up. Once it comes up, and then I'll come back so that we can continue. All right, so now the application is running, right? We can access it using localhost 4200. So I'm gonna open my browser, and then you can see I'm already on localhost 4200, and I'm just gonna press enter. And you can see we have the application running. So let's go into the console. So you just right click and go to inspect, and I'm gonna bring this over a little bit. And we are interested in the console, and I'm just gonna zoom in a little bit so that we can see what's going on here. So you can see that we get the information that we're expecting, right? Inside subscriber, we get the first data being emitted, second one, third one, and then you can see here we have this done here, and then we have this last one after 3 seconds, and then this done after the subscription. So what's happening here, if I go back, so first we got this, and then we got this 3, and then we got this, because the code is asynchronous. It didn't stop here and wait for 3 seconds. It jumped straight to line 25, and then it printed out this on the console. As you can see here, we got the first one, the second one, the third one, and then it prints the line. It didn't wait 3 seconds to print this, even though this line is after the one that's gonna wait for 3 seconds. As you can see, this line is here. So it didn't wait, but then once it was time, it went back up here to send this data again and then complete the observable. So that's an important thing you have to understand. Observable is asynchronous, which means it doesn't block the code execution, and it will come back to do whatever it needs to do if it's on a timer, for instance, in this case here. And the reason we're getting this data is because we're subscribing to it. So another thing I want to show you is this. So if I go here, which is where we're subscribing to this observable that we just created up there. And I'm just gonna go ahead and then comment it out. So I'm gonna select everything, Control/. Okay, so now it's commented out. But this code is still here. You can see we get no errors, and then everything is good. But now if I go back and well, the app refreshed, but I'm going to do it so you can see. You see we get 0 logs. We didn't get anything. And that's because there's no subscriber. So if there is no subscriber or nobody is interested in this data, then it doesn't even run, which means that all of these logs we didn't get, this entire code didn't do anything. It was just sitting there because there was no one who subscribed to it like we did here, because there's no one interested in this data. So that's what you need to understand here. If you don't subscribe to this subscriber, like you can see this is a subscriber, if nobody subscribed to it like we're doing here, then it's never gonna fire, which means this code that we have here, if nobody subscribed to them, you can see they're returning observables, then they never gonna fire. Like this code is never gonna run because there's no subscriber. So we have to subscribe to those observable and then wait for the next. I'm just gonna uncomment this so you can see. And then once we subscribe to this observable, we have to wait for the next callback or the first callback to get the data whenever the observable resolves. So that's the whole idea with observable. And this is just a really quick overview. Observables are very powerful. And just before I forget, let me show you what happens if we send an error. So if we send an error, let me see if I can bring the browser, you can see we get the 3 pieces of data, and then we get the error and then the subscriber, and then the observable just tap. Okay, so whenever we have an error, then the complete is not going to be called and it's just going to throw an error and then stop right there. You can see we have the error message as well because we're also listening on that error message right here. Okay, so we say whenever the next is called or whenever we get the data, which is going to be these lines right here, give us the data, which is what we're doing here. And then if there is an error, which is when the subscriber called the error and then pass in some data for the error or just nothing because you don't have to pass any data, then we're gonna call this function on our subscription. And when they call the complete up here, then we're also gonna call our complete here, and then we can do any cleanup work that we need to do here. So the same idea is gonna apply to those functions. So whenever we need to get the data from those functions, we know they're observables because they're not gonna resolve immediately. That's why their observables are asynchronous, which means they're non-code blocking. That means they're not gonna block the code. However, that doesn't mean we're not gonna know when the data comes back. And that's the whole point of subscribing to those observables, because we need to know when the data comes back from the server. So whenever the data comes back, this observable is gonna emit the HTTP response. In our case, we're emitting 3-4 pieces of information or 3 items, but for the HTTP call, we're only gonna send or emit 1 piece of data, which is going to be the entire HTTP response itself. So let's take a look on how we can subscribe to those observables and get the data back whenever the data is resolved or whenever the server sends us the response back and then we get the response. So I just show you in the example that I was using to explain observables to you that you have to subscribe to the observable so that you can be notified whenever the data is resolved or whenever the observable emits a new piece of data or an item. So remember, in our service, we have this function where we create an observable and then we send the request over. So the get function here that we're using to fetch the data, it's returning an observable, which is why the entire function is also returning an observable. So the same way we have to subscribe to this observable. So in our user component, where we want to retrieve this data and maybe show it to the user or manipulate it in some way, we need to subscribe to these observables. And in our class, we're gonna call the service and then call this function. And then we're gonna do exactly what I just showed you in the example. So we're gonna call subscribe, and then we're gonna call the next function. In this case, we're setting the name of this as the response because we know it's gonna be of type HTTP response. We could have named it HTTP response, which is an array of users, or we could have just named it users because we know it's going to be an array of users. And then we're going to assign that response to some field that we have in the class. In that case, we have a users field. So we're going to set this field to the response. Now, another thing you have to understand is whenever you use the HTTP like this with Angular to make the HTTP requests, by default, Angular or the HTTP client is going to map the body of the response to the type of data that you specify when you send the GET request or whatever request that you send. So if you want to see the actual HTTP response, then you have to pass in a flag. And I'm going to show you how to do this. But as you can see down below, we're doing exactly what I showed you in the example, which is we subscribe and then we're listening to the next. In our case, that's going to be the response. And then the error, which is the second one. And then the complete doesn't take any parameters because it doesn't send any data. It's just another function call so that you know that the observable is done emitting data for now or for the moment. So this is what we're going to be doing in the user component so that we can wait for the HTTP request to go over the network and then come back to us. And then once it comes back to us, then we can use that data to show on the UI. So back in VS Code, we're gonna navigate to the app component, and I'm just gonna go ahead and remove all of this code because we're not gonna use it for now. And the only thing I need to do in the constructor is to import or inject the service that we created. So exactly what we did here in this constructor, where we injected the HTTP client as our dependency injection here, we're gonna do something similar for this service here. Let's go back, and inside the constructor, as a private field, we're gonna pass in the user service. I'm gonna call it user service, and you can call it whatever you want. And I'm gonna define the type as the user service. So I'm gonna do user service and make sure this is imported. And I'm gonna remove this import that I'm not using. And now that we have this imported, we can actually use it to access those functions inside of this service. Let's go back, and right below here, let's say we're gonna define a function on get users. It's not gonna take any parameters and it's gonna return void. And what we want to do is to just call the service and then subscribe to the function. So we're gonna do this user service, and then we're gonna call get users. And then we're gonna subscribe. So here we're gonna subscribe, and then we know that we have 3 callbacks in this subscribe. So we have the first one, which is gonna return the response if everything is successful. And then here we wanna execute some piece of code. So let's just, for now, let's go ahead and just console log that response. So we're gonna have console.log, and then we pass in the response. And then we're gonna do something similar for the error and for the incomplete. So I'm gonna just copy this and paste it twice. And I know for the last one, there's no parameters, and I can just say done getting users. And for the second one, I'm gonna get an error, and we can give it a type any for now. And you can just console log that as well. And another thing you have to notice is I didn't put any type on the response. And if you hover over it, you can see that types could be smart enough to know that this is an array of user. So you notice that we're not calling this function in the constructor. We're not calling it anywhere. And what we can do is we can use the lifecycle hook. So the ng on init lifecycle hook, and then we can just call it on that init lifecycle hook, which means that whenever this component is loaded, then or is initialized, then it's gonna go ahead and run those functions. So here I'm gonna do implement on init, and then now I have to override this function, which is ng on init. I'm just gonna go ahead and put it a little bit down, and here I'm just gonna call this function right here. So here I'm just gonna remove this, call this on get users, and make sure that this function is called whenever this component is initialized. So now if we go ahead and test the application, we should see something in the console because we're actually console logging either the response or if we get an error, and whenever we're done getting everything from the observable. So I'm gonna go ahead and open the browser, and as you can see here, we already have the data, but I'm gonna go ahead and refresh it. And you can see we have the users here, and you can see that's exactly the same data that we saw on the API website, as you can see here. So just to make sure that the other endpoints is also running, so let's go ahead and see if we can create another function. So I'm just gonna copy the first one and scroll down a little bit, paste it down, and I'm gonna call this get user, and this is gonna call the get user. And then again, we're gonna log the response, log the error if there's one, and we're gonna change this to done getting user because we know this is gonna get one user. And then now we can also call this function in the ng on init. So here, I'm just gonna go ahead and copy this again, paste it down, remove the S, save everything, and then go back to the browser. And you can see that we got the first one with all the users. And then we got the first user with the ID 1, and you can see here that's the same user. So if we expand this, you can see the user with ID 1 is Lien, and we have the Lien here as well. So this is how you retrieve data. That's just a basic example of how you can retrieve data and then manipulate this data. So before we continue, I want to set up an environment variable. So let's go back to the application. And let's go over to the service. So you can see in the service here, I'm repeating this URL 2 times here. So I'm using the same URL in the 2 different functions. So it would be a good idea if we can just set a variable for this, and then we can use that variable instead. So let's go ahead over to the tablet class, and let's call this API URL. And then we're going to set this equal to this URL right down there. So I'm just going to go ahead and just copy this and paste it here. I'm gonna go ahead and remove this user. I just want to have the base URL here. A better way to do this is to set this as an environment variable. Now this would work fine. But the thing is, if we set it as an environment variable, then we can differentiate between a development environment and a production environment. So if we go to the let's go to the environment. So you can see we have an environment folder here. And if you expand that folder, you can see we have one for production. So environment.prod.cs. So we can just copy this whole URL, and let's just go over to the environment, the one that's not for production because we're not in production yet. And we're just going to pass it in here. So we're going to say API URL and pass this in here. So this is going to represent the base URL for this API. So now we can just close this and collapse this back in. So we can just reach to the environment and then set this up. So I'm going to go ahead and remove this and call the environment. You can see it's coming up here, and then get the API URL. Even though this is coming from the environment itself, so the one that we just set, and not from the production, whenever we build this application and then we do like ng-build to build this application, then it's going to look into this prod. So whatever is in prod, then that's what it's going to look. So what we can do here, we can just copy the same API URL, and then we can just go to the production, and then here we just paste it. And then this URL would be something like the real URL, like the production URL. So we can say like production, that's something, right? So this is not a valid URL, but I'm just showing you, you would give them the same name. So what would happen is whenever you're done building this application and testing it and you want to deploy it, so you have to run ng-build, then the Angular CLI is going to look into this application and it will set this value to the environment variable that is in production and not the one that is in development here. We can just close those things now. And now we have our environment variable. So here we can just use this URL. So I'm just going to go here and just select both of them and then just pass in this API URL. And we have to put a $sign in front of this, just like that. And then we know that this doesn't end. So if we go back into it, you see that this is just the base URL. Okay, we could have named this base URL. And then here we know we have to pass in /user. So I can just /users to get all the users. And then here again, I can just pass in /users/1. So this is how you use your environment. That's just an example of how you can use the environment that you see here, so that you can use different properties depending on what you're doing or what phase you're in, either if you're in development or if you're in production. So now if we go back to the application, you can see that everything is running exactly like before. Okay, so we got the 10 users and then that one user that we fetch. So far, our application has only been making GET requests. So we've only been sending requests to retrieve data and then display that data somehow. So let's see how we can make post requests. In our user service, to make a post request, it's going to be very similar. So we're going to define a function and then we're going to call the post on the HTTP this time. Now notice that the name of the function is different. So we give it an appropriate name since we're trying to create resource. And also we're passing in the payload that we're going to send with the body of the request. So you can see here, we're passing in a user, and then we pass that user as a second argument to the post function. So you can see with the post, we pass in the URL and then we pass in the payload or the request body. So it's going to be very similar to the GET. The only thing is we're going to use a different method. So since we're making a post request, so it's going to be a post, and then we're also passing in the payload. As you can see here, we make the method or the function take the payload, and then we pass that payload as a second argument to the post. Now there's more arguments that you can pass into the get function or the post function, but for now, the only other argument that we're going to pass with the post request is just the payload that we're passing in and the request body for the backend to use it and then create that new resource on the server. Another thing I want to point out is that you can see that this function is returning an observable of user, which is the user that will be created on the server. Whenever you're trying to use an API, you have to go through the documentation so that you can understand exactly what's going to happen when you make certain requests. So I'm just putting this here because this API that we're using, the JSON Placeholder, it's going to send us back the data that we create on the server. It might be possible that on a different web service or a different API, they might send you a different type of data. So it might not be the data that you just created. It can be a Boolean that lets you know if the call was successful or not. It can be like some code. So it depends on the API. But typically, whenever you create some resource on the server will send you back the resource that you just created as a response or as the response body in the body of the response. And one other thing to notice is that whenever we send this request and we send the payload, so let's say the user looks like this, right? So we have a user object, which is the payload or the request body, and then we're going to send it with this request, right? So we want to create this user with a simple name and then a gender. So usually when servers create resource, they usually associate a unique identifier with that resource. So a typical response would look like this. So whenever we send the request, we send the name and the gender, but the response might look like this. So in the response, you see we have an additional property on the object itself, and that's the ID. And that's because whenever the backend or the web service is saving some data or creating some data, it usually associates that data with some ID so that later when you need to retrieve that data, then you can pass in that ID and then retrieve that specific data. And that can be an ID or any unique identifier. And if this data is being saved in a database, then it's usually the primary key or some unique identifier that you can use to target that specific resource or on a file if the data was saved in a file. So let's go ahead in the code and give this a try. So back in VS Code and back in our user service, I'm just going to go ahead and copy the second function here, and I'm going to go down a little bit and paste it. And let me scroll up. So here we can just rename this function. So we know this is going to create a user, so we can just call it create user, and we know it's gonna take the user as a parameter. So we can say user, and we know this is gonna be of type user, and it's gonna return an observable. The body of that observable is gonna have a user in it, and then here we can just change this from a get to a post. Okay, so we're sending a post request, and you can see I'm already getting an error because I'm not passing in the payload. So here I can just put a comma and then pass in the user as the payload. And this is supposed to go here, and I have to remove that extra one. And we don't need this ID either. So now we have our function. So it's gonna call the post on the HTTP, and then it's gonna pass in this user as the payload. So let's see how we can use this. So I'm gonna go back to JSON Placeholder. And let's go here, and I want to scroll down and look at the users. So here's the users. So I'm going to open it in a tab, and I'm going to scroll in so you guys can see. So you see we have all those users, so we can use any of those users so that we can test this function. So I'm going to copy the first one, and I'm just going to go back to the project and then go back to the app component, and here I'm going to define that user. So I'm going to say this user is going to be private because I want it to only be used in this class. I'm going to say this is user and it's of type user, so our type, and then I'm going to set it equal to this object literal here. So you can see now we have this user. And another thing I'm going to do, I'm going to remove those double quote and replace them with single quote. So I'm going to do Control F, and I'm going to say search all of the double quote and replace them with a single quote. And then I'm going to click this to replace all and get rid of this. Okay, so now you can see that we have this user, which is of type user, so our shape, and then we're passing in all of this information. So I'm going to go ahead and change the name. So let's say this is going to be Junior. Let's say the username is Junior, which is me, and that should be enough so that we can see that this is a different piece of data. Now notice that we're getting an error, so we need to import that. So quick fix, import. So now we have the user imported. But the other thing is we don't want to send this ID, right? Because we know that this is going to be provided on the server. So whenever we send this request, the server is going to create this ID and then save this new resource with that ID, right? So I want to not send this ID. So if I remove this ID, then we get an error because we're not adhering to the actual shape of a user, right? So what I can do is I can put it back, and let's go into the interface. and I can put a question mark here. And what this means is that this ID is optional. So there's a possibility that whenever we're trying to map some data to this shape, we don't have an ID, okay? And that should resolve our issue. So now if I go back and I don't want to send the ID, I delete it, you can see it doesn't complain anymore. So now we have this data. This is the resource that we want to create on the server. So we can pass it to our function. The same way, we're going to do something very similar. So let me copy this function here, and I'm going to go down and then paste it. And I'm just going to change this name. So I'm going to call this onCreateUser. And we know it's going to take the user. What I can do is I can either pass the user that I just created on this class, or I can just pass it directly inside of this service call. So here, I'm going to remove this, and I want to call the CreateUser. So CreateUser, and I know this takes the user. So I'm going to specify the user that I have on the class. And I'm going to change this to done creating user. So we have this call now that we can make, and we pass in this new user that we defined up here. And then this new user should be created on the server. So now we have to call this function. So let's go up, and I'm gonna go ahead and just maybe not call the second one, and let's call the new one that we just created. So onCreateUser. So another thing I want to do is I want to compare to see all the users that we have and then the new one. So on the call to get all the users, so here when we're getting all the users, which we're calling up here, I want to change this log to a table so that we can see a little bit better. If everything goes well, we should go back and we should see that this new user should be created. So let's go back to the application and let's go back, and you can see it's already here, but I'm going to go ahead and refresh. All right, so you can see we have the first 10 users that we retrieved from the backend, and then we have this new one that comes back to us. And this is the new one that I created. And you can see, even though I didn't pass the ID is still here, which is 11. So you can see we have 10, and then there's the new one, which is 11. And you can see all the information is here. So here's the junior that I put as the username, and here's the name that I put in, which is junior. We could have changed all of this other data as well, but you know, this object is quite big. But you can go ahead and change whatever you need to change on here and send the request again. And you should see that the user should be created with the ID 11, which is the next number on that list here. So as you can see, we have 10 here, and this is the 11th user. So this is how you make a post request to create a resource on the server. Let's go ahead and look at the put request. So the put request is going to be very similar to the post request. So we're going to create a function. We're going to give it an appropriate name. In this case, it's update user, because that's the action that we're trying to take. And then we're going to make it return an observable just like before. But this time we're going to call the put on the HTTP and then pass in the URL. And we also have to pass in the payload. As you can see, we're passing in this payload inside of the function as the request body to that HTTP call. Now, one thing you have to know is whenever you're sending a put request, you have to send the entire data. So for instance, if our user looks like this, and remember earlier we had the name as Junior, but now we have Richard. So if we're sending this data and we want to change this name to Richard, we have to send the entire data. As you can see here, I'm passing in the ID, pass in the new name this time, which is Richard, and then I pass in the gender. So if we don't do that, meaning if we don't pass in all the properties of that specific user, then everything that we don't pass will be set to the default value. So if your backend is, for instance, using Java, and let's say I didn't pass the gender, then this gender, which is a string, in Java, the default value of a string is null, then this would be null. So null will be saved in the database. So, and that's the main difference between put and patch. Whenever you're using put, you have to send in the entire data. Otherwise, everything else that you don't send will be set to the default value. But with patch, it's a little bit different. With patch, you don't have to send the entire data, and we're going to see that in a second. But just remember that whenever you're trying to update data and you're using the put, you have to make sure that you send the entire data, meaning all the properties on that specific piece of data. Now, that's just the default, but whoever is building the web service, they can make a certain endpoint accept the put request to update a user, and then they can put in any logic that they want to make sure that the data is saved properly. So it really comes down to the implementation of that specific API or web service. But typically, whenever you send a put request, you have to send the entire data. So all the properties on that data, which is the main difference with patch, because with patch, you don't have to send all the properties on that specific piece of data. You might just have to send the ID and then whatever field or value you want to change, and everything else will stay the same. But with put, we have to send the entire data. So let's go ahead and give this a try. I'm going to copy the create function, and I'm just going to change the name to update. So let's remove this, and I want to put update. This is gonna return an observable, and that's gonna be the updated user. Now, the only thing is you have to always double check with the API that you're using so that you understand how to send the request to them. I've already looked at the documentation, so I know how to send this request, but what I'm trying to make you understand is that whenever you're gonna use some API, you don't go off of what you know as far as like how to send a specific request. You have to actually go on the website of that specific API and then read their documentation so that you understand how to send that specific request. So here we're gonna send a put request. So I'm gonna change this to a put. And when you send a put request, you should also pass the body. And another thing you guys can do, if you just put your mouse over this and you press Alt F12, you can look at the definition of that specific function and you can see what you need to pass. So you can see here the put, it takes a generic, which is why we're passing our type of data. And then you can pass in the URL, and then you can see that you pass in the body. So that's how you can see what you need to pass. And we're gonna look at those more. So here you can see that we're passing in that body. Now, the other thing is if we go to the documentation, as you can see here for updating a resource, so you have to pass in the ID of that specific resource. So beside all of the body that you have to pass in with the request, you have to pass in the ID. So let's say that for this user, we're gonna pass in the ID here as part of the URL. So I'm gonna do / and then I'm gonna pass in the ID. So I can do the user and then ID. And like I said before, you always have to check the documentation of the API so that you know how to use it. So now we have the update so that we can update a user. So let's go ahead and use that update. So I'm gonna go back into the app component and I'm gonna scroll down and I'm just gonna copy the create and then paste it down. I'm gonna scroll up a little bit and then I'm gonna call it on update user. And then here I'm gonna pass in the update. So update and pass in the user. Now what I wanna do is, you know that we have to pass in the ID of the user. So let's go ahead and scroll up. And here now I'm gonna create an ID for that specific user. So I'm gonna do ID and then give it some value. So let's say we want to change these, let's say the 5th user. So let's change maybe the name, the email, and let's change something else. Let's go into the company and let's go ahead and change that. Okay, so now that we have this data change, so now whenever we send the request, the 6th user should be different. So let's go back into the browser. Well, we have to call that function first before we forget. So I'm not gonna call the create user, so I'm gonna go ahead and comment this out. But I'm gonna get all the users after I call the update user. So this is supposed to be uppercase, and we're just gonna copy this name. And I wanna make sure I update this before I forget. And let's go ahead and scroll up. And here we want to call that function. So this on update user. I'm gonna save everything and then go back to the browser. And let's see, I'm gonna go ahead and refresh. Okay, and you can see that we have the update user. So there's the first one. So I don't think the user is going to be updated because this is just a fake API. So whenever we fetch all of the users again, as you can see, the name is still the same, but we get the data back. So for the 5th user or the user with ID 5, we were able to change the email, and you can see the company name is different as well. And you can see the name is also different and the username is different. And those are the values that we set. So if we go back and we change this ID, so let's say we want to change this, the last user. So we pass in 10 and let's go ahead and refresh. So you can see the 10th user is Clement, and here we're changing the name to my name. Well, just Junior is my name. But you can see it does the same for this specific user, which is the last user. So in a real backend, whenever we update the data like this, and then we fetch all of the data again down below, this data will be different. So obviously this is not being persisted. And if you read the documentation, it will tell you that the resource is not really updated, but they just fake it as if it was updated. So that's why whenever we fetch the data again here, we'll still see the same data is still there because, you know, this is a fake API and you just use it for testing. But that's how you would update a user using the put method by passing in all of the parameters of that user. So like I mentioned before, the put and the patch, they're both used to update, and there's just one difference between the put and the patch. In our user service, we will create another function. We can call it update user, and then we're going to call the patch on the HTTP, and then we pass in the payload to that URL. So it's exactly the same way as you would do a put, but the only difference is we don't have to send the entire data. So here you can see our data can look like this. We can send the user ID, and then we're just changing the name. We don't have to send all of the rest of the data. And because you're doing a patching, what the system is gonna do, it's gonna go ahead and just replace the properties that you send on that specific data. So here we're just assuming that we're sending the ID so that we can identify that specific resource on the server, and then we just say, hey, update that name, and then what the server is gonna do is just update the name and then leave everything as they were. And that's the main difference between the put and a patch. The put, you have to send the entire data, and whatever you don't send, they will be default to the default value. And with the patch, you don't have to send the entire data. You just send whatever you need to update, and the system will leave everything else as they were and update only the properties that you want to update on that specific resource. So let's go ahead to the code and let's give this a try. So back in VS Code, I'm gonna copy this function again, and I'm just gonna go down and call it update user. Since we can't have the same name twice, so I'm gonna do maybe patch user or something. So patch user, so that we can send the patch request. So here we're gonna change this to patch because we're trying to patch the user, and then we're passing in the user ID and the user. How do I know what I have to pass here? Again, because I looked at the documentation. So if we go back to the documentation, you can see for patching a resource, we have to pass in the ID of that resource. And then you can look at the body of the request. We're just passing in the property that we want to change. In that case, they're changing the title, which was very different if you look at the put. So with the put request, we pass in the entire data. Okay, so whatever we don't pass, they will be set to the default value on the server. So for the patch, we don't have to pass in all of the properties on that specific data in the request body. So let's go back to the code and let's just make sure this looks good. Okay, so we pass in the ID of the user we want to change, and then we pass in the payload. And in that case, we don't have to pass in the entire user. So we're gonna use this function. So let's go back into the app component, and I'm gonna comment the update for now, and I'm just gonna copy the update, paste it down, and I'm gonna call it on patch user, and then call the patch user, and we pass in the user as well. And I'm gonna change this to patching user. That's what we're doing. And I'm gonna go ahead and scroll up, and I wanna change this data a little bit. So we know that we don't have to pass everything. So let's say we're gonna change the second user. So I'm passing a 2 here, and I'm gonna change the name, and I'm gonna just remove everything else. So here I can just take all of this off. Okay, so then our user is complaining. So let's change the value for this. Let's put any for now so that we don't have to go back and change all of those properties, and then we can pass that user in the request. So we know that for the second user, their name, their email, and their username is gonna be different, and everything else is gonna be the same. So if we go down below here, so we need a call to get all of the users so that we can compare. And then I'm gonna call the update or patch user. So I'm gonna do this, that patch user, and call that function. I'm gonna go ahead and save everything and then go back to the browser and let's refresh. All right, so you can see the second user, when we make the call the second time, I'm gonna change this to log so that we can explore this better. So I'm gonna copy this, change it here, oops, and then go back. All right, so you can see the first is the patching. So that's the second one that we're patching. And then let's compare this to the second user. So the second user is right here. We know that the data is not persisted for real. So that's why the user is still the same. So the name didn't change. But you can see that in the user that we got back everything else with that user the way that we had it before. So only the name, the username, and the email were changed, and everything else is the same. And we can compare. You can see here, like if we expand the company, you can see the company is still the same. Okay, so we didn't change anything on the company. You only change specific properties on a specific resource. You don't change everything. But with the put, you have to send the whole object. With the patch, you don't have to send the whole object. Usually you just have to send the ID and then the parts you want to change. In that case, we change the username, the name, and the email, but everything else is still the same. You can see we can compare those. We can look at the address. Address is still the same. As you can see here, it's the same address. So everything else remains. So this is how you would do a patch. And later in the course, I'm going to set up my own backend so that I can show you guys some more advanced stuff. But this API will do for now. Let's now take a look at the delete request. So the delete request is going to be very similar. So just a function, we're going to give it an appropriate name. And this time we're going to call the delete on the HTTP client. Now notice that with the delete, you usually pass the identifier of the resource that you want to delete. And in that case, we're passing in the ID and we're passing it in as a path variable. So it's part of the URL itself, but you can also pass it in the header of the request. You can pass it as a request parameter, and we're going to look at request parameter in a minute. So you usually don't see this ID in the request body. You usually see it either in the header or in the request parameter, or you can see it as a path parameter, which is the example that we're showing here. This resolved to an observable, so you have a value that's true or false, and that's going to tell you if the operation was successful or not. In this case, if the delete was successful. And also, you usually don't get any data back. So you don't get any data back, and that's usually what you would get in the response body. So you can get like some value that tells you everything was successful, but you're not going to get like an entire object back or anything like that. However, you can do that. Like you can implement your web service so that whenever they delete a resource, then you can send that deleted resource back to the user. So it really comes down to how you want to implement your web service. So let's go ahead and take a look at this in the code. So before we go to the code, I wanted to take a look at the documentation on JSON Placeholder. So whenever we're sending a delete request, we pass in the ID to delete that specific resource. But I have no idea what this is going to return back to me. As you can see here, they didn't mention. So if I scroll up a little bit, you can see here they mentioned the output whenever you're doing, for instance, a patch request. But for the delete, they didn't say what you get back in return. So I'm guessing maybe you get nothing back except like the HTTP headers. So you get no response body. So let's go ahead and try this out and see what we get back as the response from the server. So let's go back in VS Code, and I'm going to go back to the service, and I'm going to copy this patch request here and paste it down. I want to change this to delete. So let's change this to delete because we're trying to delete the user. And here we have to pass in the ID. In that case, that's a number. So we're going to set the type, and then we're going to pass in this ID here. We're going to remove the payload and send the request and make sure we change this to a delete. Okay, so we're sending the delete, we pass in the URL, and then we pass in the identifier of the resource. In that case, this is the ID. Remember, I said that I don't know what this is going to return to me. So as the response body, I have no idea what I'm mapping. So in this case, I can just set this to unknown, okay, because I don't know what I'm getting back. So we're going to set this to unknown because we don't know what the server is going to send back in the response body. Okay, so we know we're going to get some HTTP headers. But in the response body, which is what we're doing here when we try to deserialize this response body to a specific type, we don't know that type yet. So let's go ahead and try this out and see what we get. So let's go back to the component, and I'm going to scroll down, grab one of those guys, scroll down a little bit more, and then paste it. And I'm going to call this on delete user. And then here, I'm going to call the delete, and I'm just going to pass in a number here. So let's say we're going to delete the 5th user, right? So we're deleting the 5th user, and here we're going to say deleting user. Okay, so we're done deleting user. So this is going to be on delete user that we're going to call. We're deleting the user with ID 5, and we're sending that over to the server. So let's go ahead and see what we get back. As you can see here, whenever we get a response, whatever that response is, we're going to console log it. And if I hover over it, you can see that it has type unknown because we don't know. So let's scroll up a little bit and let's call that function. So I'm gonna comment out the patch, and I want to see all the users in case I have to do some comparison. So I'm gonna leave the first one here, and I'm gonna go down and then call the delete. So I'm gonna do this dot delete. And actually I have it copied, so I'm gonna paste it and pass it here and save this. So let's go back to the browser, and we got nothing. You can see here on line 73. So if we go back, you see line 73 here, we got nothing. Okay, so you see that when we try to console log this, and I can put something here just so we know that we're console logging this. So I'm gonna say response from delete and then pass in the response. Okay, so I'm gonna save this, go back to the browser, and I'm gonna refresh this so it's clear. So you can see we have the response from delete here. I'm gonna zoom in a little bit, and you can see it's an empty object. Okay, so we have nothing returns back to us. So what we can do now that we know what kind of data we're gonna get returned, we can just set this to the appropriate data. So instead of unknown, we can go ahead and change this to void. Okay, because we know that's what we're getting. So now whenever we do this, so you can see it's gonna say void here. So it's gonna give us the same thing, like nothing's gonna happen here, right? So let's go back and refresh. You see it's because it's void. Okay, we still get nothing. However, if you go back to the network and we're gonna refresh this one more time, okay, so we can see here the request that was sent. So we can see that we sent this delete request for the user with ID 5, and then we got a 200 response. So that means that the request was successful. And again, we have nothing. We have an empty body, which means it returned void. So again, you can see that in the slide, I show you that sometimes you get a Boolean, sometimes you get the user back or the data that you delete back, but sometimes you get nothing, which is void. And usually you can see that whenever we check this out, you see it gives us a 200, and we're gonna go over some of the HTTP status code later. Any 200 range response code is successful. But in this case, whoever built this API, they decided to send a 200 response on a deletion. So this is how you send a delete request. We can't really talk about making HTTP calls or HTTP requests without mentioning HTTP headers. So what are HTTP headers? So HTTP headers, they're just a way for the client and the server to pass additional information to each other. So whenever you're making requests, beside everything else that you can put in a request, you can also add HTTP headers in the request. And the server can also send you headers in the HTTP response. So you would have a key and then a colon, and then you would have the value. So for instance, you can have the content type, which is a default header, and then you can pass application/JSON to tell either the client or the server that the content of the body of the request or the response contain data in the JSON format. Another example can be for authorization. So there is a default authorization header that you can pass, and that usually like a token or an API key that you can pass. So headers are pretty simple, however, they're very powerful. So I'm gonna show you some example whenever we're doing some more advanced HTTP requests, how headers are like super important to tell either the client or the server important information about the request and response that they're passing to each other. So let's go ahead and see how we can pass HTTP headers with Angular when we're making HTTP requests. So before we go into looking how we can pass HTTP headers with Angular, I wanted to show you guys this website called developer.mozilla.org, where you can go to learn a lot about just web technologies. So right now, as you can see, I have the HTTP headers page up, and you can go on this page to learn more about HTTP headers, since this course is mostly focused on how you can use the Angular HTTP communication. So I'm going to show you how you can pass headers, but HTTP headers, they're like a really broad topic. So if you want to learn more about HTTP headers, you can head over to this website and then take a look here. As you can see, there's like a long list of HTTP headers, and they're divided in subcategories. So you can go ahead and take a look here and see which one you might want to use in your application depending on what you have going on. So you can see this list goes on and on and on. And if you look at the definition here, it's exactly the same definition that I just gave you, and that's my source actually. So if you want to learn more, you can go ahead and go on this page. This has nothing to do with Angular. This is just the definition of HTTP headers, how it's defined by whatever rule, which is RFC 668, as you can see here. So if we head over to the Angular documentation official website, and I looked for the HTTP headers, and as you can see, Angular provide a very convenient way to pass HTTP headers with the request that we're making to backend. Now, remember, HTTP headers can be sent with a request or they can be sent with a response, right? So in this case, since we can only make requests with this client application, we accept responses, but we don't, send any responses because this is the client side application. We make requests and we accept responses from servers. So we're not going to be looking at how to actually set them and send them as a server, but as a client, you can still set them and then send them over. So as you can see here, we have this nice HTTP headers class from Angular. It has a constructor, and then it has some methods or functions that you can use. And there are many different functions that you can see here. So we have one to append, one to set, and one to delete, and etc. And we're going to take a look at those in a second. But you can also scroll down just to take a look at, exactly the definitions of those methods and how to use them, etc. And you can just go in there and just browse for yourself if you want. So what we're going to be doing is we're going to go ahead and use this class, which we have in Angular, and then we're going to see how we can pass in some headers to the request. Now, another thing is we're not going to be processing those headers because we don't own the backend, and we don't necessarily have to go into the backend to do anything with those headers either, because I'm just showing you how you can pass those headers to a backend server, which means this is focused on the front end side of things. So how we can set headers and how we can receive them, but not how we can set them as a server, because this is the client application. So we're going to take a look at this class and see how we can pass in HTTP headers with Angular. So I'm going to use the getUsers function so that I can demonstrate the headers. So one thing I want to show you is the definition or the signature of those methods. So if you put your cursor over this and then F12, I'm going to scroll down a little bit. You can see we can pass headers, we can pass params, and we can also pass observe. And if I scroll down a little bit more, you can see we have a few other parameters or options that we can pass to these methods. And you can see some of them have already been set. So the observe, you can see there's a string body that is set there. And that technically means that it's going to convert the HTTP response. It's going to take the body and then parse it to whatever type that we specify. So you can see that it doesn't have a data type, but it has an actual value. So you see the report progress, they tell you it takes a Boolean. But if you look at the observe or the response type, you can see that right here, they're passing an actual value. So that's why we have some of the default behaviors that we have. But for now, let's just focus on headers. So you can see the headers is of type HTTP headers, or you can pass in an object here. You can see you can put a string as the key, and then you can pass in a string or an array of string as the value. And we can also click inside of that header to go to the definition file. And you can see if you scroll down, there is a constructor here. You just pass an object with a string, and then the value is going to be a string or an array of string. The key is going to be a string as well. And then the value is going to be a string or an array of string, as you can see here in this constructor right there. So let's go ahead and close this. And this is always a good idea to understand exactly what's going on behind the scene so that you know exactly how to use those functions. So I'm going to go down here, and let's say I'm going to do a constant, and let's call this constant my headers. So what I can do here, I can just call the constructor, oops, that's HTTP headers, and then I can just leave it like that, right? And then I can set more values to it or more headers to it later. But another thing I can do is I can call some of the methods on the actual constructor itself and then pass in the values that I want to pass. So let's use the constructor first, and then we'll use the other methods or functions in that inside a class. So we saw earlier that we can pass in an object, so we're going to pass in an object. And we can pass in a key, which is going to be a string. So I'm going to say my header, and then we can pass it in a value, which is a string or an array of strings. So let's pass in a string first. So I'm going to say this is the value. Well, this is a bad example. I'm just going to remove this and then say header value. So now we have this my headers that we can pass to this request. Again, if you go over into the definition, you can see that the key for headers, after you put in the URL, you pass in these options here, and then it's an object for everything that we can pass here. And then the key for headers is actually headers. Okay, so we can just copy this, and we're gonna say, hey, here I'm gonna pass in some more options, which is an object, and then there's one for headers, and then we can pass in my headers. Okay, so that's how that works. So now you can see we're not only passing, the URL and everything else, we're also passing my headers. So now if we go in the browser and the request that we're sending, we should see this my header and then header value. So let's go over to the browser. Okay, so I guess the page refresh. Now to see those, you have to go to the network tab. So we're gonna go to the network tab and into the users, because that's the one that we put the headers in. And it's gonna collapse this one. And now if you look at the request headers, you can see our header down below. So my header and then header value, which is right here. Now, another thing you guys need to understand is that the instance of the headers is immutable. So for instance, if I go and copy this and I go on the next line and then I call the set method, and then let's say I'm gonna set another header. So I'm gonna say ID, and then I'm gonna set this equal to, let's say 1, 2, 3, 4. Now, remember I just told you it's immutable. So whenever you call the set on the headers, what it's going to do is it's going to return a new instance of that class. And as you can see here, we're not setting that new instance to a new variable. So technically what I'm trying to say is this code is wrong because this is immutable. Like we can't mutate it or we can change it. We have to set it equal to itself in this situation. So we can do my headers, and then let's make this a let because we're changing it now. And then we set it equal to this. So you can see if I leave this out and I set this header, or I could use the append as well, you'll see that we won't see this. So if we go back and we look at the user's request and we see the request headers, and you can see that we don't see this header because whenever you call the set or the append, it's going to return a new instance of this. So if you want to, on this line 15, we want to set more headers, we actually have to do something like this. Insert equal, because it's gonna, this set is gonna return a new instance of the object that we defined here, and then we're saving it again inside here. So now if we go back, go into the request headers, you can see the ID is here and my header is down below. So that's the one thing you really have to understand. These instances that you create using the HTTP headers class, they're immutable, like you can't really change them. So let's go ahead and copy this. And let's go to the next line. We can call the append. So the difference between the set and append, when you call set, if you already had a key ID, it's gonna override it. But when you use append, it's just gonna add it to that specific header. So now if we change this number to like say 000, you'll see that we'll have ID equals those two. So let's go back and I'm gonna refresh this. Go to the users. Now you see the ID is 123 and then 000. However, if I go back and call set again on this, it's gonna override this 1234. So if we go back, we go to users, you can see now it's only 00. So that's the difference between the append. Appends mean you're adding to that specific key, and then set means you're gonna override it. That's just the definition. Now there's more you can do with this. So if we go inside of the class again, you can see there is a has that you can call. You pass in the name of the key of the header you're looking for, and it's going to tell you if the header is in the HTTP request or not. And we can use get to pass in the name, and it's going to return a string if it can find the header, or null if it doesn't find it. You can get an array of all of the HTTP headers by calling keys, and there's the get all. You can see that we have a few options here. So I'd say you guys can go ahead and play around with this, but some of those, for instance, to keys, get all, and the get and the has, you would probably use those whenever you're receiving a response so that you can check for specific headers and stuff. It's not a good use of your time for me to go to each one of them, but at least you know how to use it. And lastly, remember that we can pass in an array here instead of just one string. So I put some bracket here, and I can pass another one. So I'm just gonna copy that one and then pass another one here, let's say 2. Okay, so that works as well. And the only way you're gonna know how to use those classes and stuff is to just go into the definition file. So you can see I can go into the definition file. That's what the D stands for. And you can see that I'm using this constructor, which is why when I clicked on this, it determines that I'm using the constructor, because as you can see here, I'm using the constructor because I called a new, and then I pass in the class name, and then I pass some values to the constructor function. As you can see here, this is the constructor, and it takes some values. So you can see I can pass in a string or an array of string. So that's how I know, or you would know how to use this. So it's pretty simple. You set your headers and then you pass in them as options into the HTTP request. And this is also true for the other types of HTTP requests. So for the post, the put, etc., they all take options. So if I show you here, you can see that you can still pass options after you pass this URL, anybody if you have any, and then more options, which is the same signature that we have. So we're gonna go ahead and look at all of those options, and I'm gonna show you how important those options are, because they're actually really important for our requests. Let's go ahead and look at HTTP parameters. HTTP parameters are sometimes called query parameters or request parameters. It's a way for the client this time to pass additional information with an HTTP request. And you usually use them to pass in some filter parameter. So let's say, for instance, you might want like page 1 and size 10 to specify to the server that you want the first page of some response, and then you want 10 items per page. So usually use them for filtering. I've seen them being used for like so many different reasons, but typically they're used for filtering the information that the server is going to send back to you. And they have a very similar format. So you're going to have a key and then a value, and it's going to look like this with the URL. So as you can see here, I have an API here and I'm trying to fetch some users, but I tell the server that I only want page 2 and I want that page to have 10 items inside of it, as you can see here. So those are HTTP query parameters or HTTP params. That's what Angular calls them, but they call request parameters or query parameters. Now you have to understand, we don't need to use the HTTP params class that we get with Angular to set those parameters. We can just set them ourselves manually by doing some string manipulation with the actual HTTP request that we're sending in the URL. But since we already have this class, it makes it a little bit more convenient for you to do that. So I'm on the Angular website, and here we have the HTTP params class, and you can see it's very, very similar to the HTTP headers class. So you have a constructor, and then you have a few functions that you can call. So we have get to get one specific parameter, and then we have append, we have set, append all, and delete, etc. So again, you can go down here and then, look and see how to use those functions. But yet again, I'm going to show you how to use them. They're fairly simple, both of them, both the HTTP headers and the HTTP parameters, or the HTTP params. That's what Angular calls it. But let's go ahead in the code and let's see how we can set those. So back in VS Code, I'm going to go ahead and remove all of this. And I'm going to call this my params. And I'm going to call the constructor again. So HTTP params. Let's go ahead and take a look at this. So here in this constructor, you can see that it takes options, which is of type HTTP params options. So we can go ahead and take a look at this class. So you see, it takes a string array, and then you can pass it a string or a read-only string array. So let's go back to the service. So what we can do here, we can just say set again to pass in some values. So we can say, hey, I want to set a page, and let's set this to, let's say 5. And also another thing you can do, you can keep chaining those. So I can call set again or append, and I can pass in some new values. And then let's say sort, and let's pass a value, let's say true or something. Okay, so we're telling the server, hey, we are trying to make this request and we want page 5. Well, that has to be a string, by the way. And then we're sorting it. Let's say the backend understands those parameters. And then here, all we have to do here, so I'm going to show you again. If we go inside the definition of this get, you can see that it takes params. Okay, so the key is params, and then we pass in our params. So let's go back, and instead of headers, we're going to pass params as our options, and then we can pass my params, just like that. Okay, so now if we go back to the browser and go back to our application, let's refresh, and let's go here. You can see, if I expand this, you can see we have page 5 in sort equal true. Okay, this server doesn't understand this, so obviously these are not being used in the backend, but you can see they're being set here. So let's go back to the code, and it's the same with the append. So I can say my params and then equal my params that append, and then I can pass in some key and some values again. So I can say name, and then I can pass in my name here. Okay, so that would work as well. But the only thing you have to remember is this is immutable. So if I have this code doesn't work, okay? Because you can't change the instance itself. It's immutable. So whenever we create this my params, it's immutable, okay? So it's gonna do this and then return an instance. And if we call append again, it's gonna return another instance with the additional value that we passed in. If we keep it like this, you'll see that, I can actually show you that. So if we go back and refresh the page, and you can see we don't see that one that we passed it with my name. But if we change this to my headers, my params, okay, so whatever instance this is going to return, you reassign it again to this value here, which is why I define a let here and not a const, because we're changing this value here again on that line. So now it should be there. So if we go back, as you can see, name equals junior. And again, the difference is with set, it's going to override the value if the value already exists. With append, it's just gonna add one more. So if I do copy this and then paste it down, so you see the keys are the same, but then let's say I pass in some random name, John, okay? And save that, go back to the browser. You can see it passed names, junior, and then name equals John. If I extend this, okay, you can see it here. So it puts the name 2 times. So now let me show you how to use the constructor. So let me go back and let's go into the signature again. So you see it takes the constructor for the HTTP params. It takes an HTTP params option, okay? And we're gonna call it options, as you can see here. So if we go into this class, you can see it takes a read-only array or a string, and then you can call from string or from object. Okay, so I'm gonna show you how to use those as well. So let's go back to the service, and on top of the class, let's go ahead and define some params. So read only, because it has to be read only, and then more params, let's say, and then let's say this is equal to some array. Okay, I'm going to show you how to use the from object. So here, let's say we're going to pass in two values, so name or something like test, and then pass in test again, let's say test2. Okay, so now we have this read only array. So what we can do when we call the constructor is gonna remove these. So inside of the constructor, we can do something like this. So remember, it takes some, let me show you again, HTTP params options. And when we look at those, you can see you have from string and then from object. You can see the from object is an object with an array of string and then a string or a read-only array of string. So we're doing the read-only array of string. So here, I'm gonna remove those so that you can be clear. So we can do something like this, the params, and then set it equal to an object, because remember the option is an object, and then this needs a key and a value. So remember, the key can be an array of strings. So we're gonna say, let's say this is test list, and then set the value to this, that, more params. Okay, so this is the read-only that we have defined on the class. So now what we can do is I'm gonna remove the constructor and then put it after this, and inside of that constructor, we can call the from object. Okay, so I can say from, you can see I have the option coming up because it's part of the signature, and then I can pass in the params just like that. So now if we go back to the browser and refresh, and if we look at this, you can see he was able to extract the value and then set them. And if you go back, we set this as the name. So test list is the key and the value is test and then test2, or maybe we should name this test1. And then if you want to use the constructor that way, then you have to call the from object. And what it's gonna do is just gonna extract those values and pass them in this here. Or what we could do is we could just pass in this entire object in here as well. So we didn't have to define this extra variable here. We could have done something like this, and that would work as well. So this is the key, and those are the values. And since this query parameter is gonna set it like multiple times, so it's gonna fit test list, and then it's gonna do test1, and then test list, test2. As you can see here, that's exactly what we get. Okay, so test list, test1, and test list, test2. And to call the from string is very similar. So if we go again in here, you can look at the HTTP params options. So if I go in there, you can see we just did the from object here, and the from string is just a string. So you just put a string and then call the from string, and then you pass in the list of all the strings. So let me show you that as well. So let's do from string, and then here we just pass in a string value. So we can do something like name equal junior and ID equals, let's say, 58. So what from string is gonna do is gonna extract those values and then add them to the URL. So now if we go back and we look at this, you can see name, junior, ID 58. So that's the from string is simpler than the from object. The from object just takes the values out of an array, and you can set it just like this. You put the key and then you put the array value. And it's gonna set it for every value. So it's gonna take test list, test1, and then test list equal test2. From string, you just pass in the string like this, and then it's just gonna extract the values, put them in the URL. And again, if you don't wanna do it that way, you can just call the constructor, and then you can call set, or you can call append, and you can just pass in the key and the value. And you can change those together as well. So if I do this, I can also call it again, and then call it again, or call the set method. And like I said, you can also do the string manipulation yourself. So you go in here and then pass in your values inside of this function right here, and you can do the string manipulation, but that's a little bit harder. And that's exactly why we have this HTTP params here, because we can use this class to set those values, and it's gonna make everything easier for us. And you can go inside of this class and you can use some of the other functions that you see in here, but it's pretty straightforward. It's not really complicated. It's very simple to use. We're gonna continue looking at all the other options, and I'm gonna show you what they mean. So as you can see here, we have report progress, response type with credentials, and observe. So we're gonna take a look at those as well. Before we go play with the options that we can pass to the request, I want to show you exactly the different values that they can take. So right now I am on the HTTP guide page. So if you go to angular.io/guide/HTTP, you should land on this page. And I'm going to scroll down a little bit, and what we're looking for is this, the request data from a server. So you can see the options, and you can pass headers, observe, params, report progress, response type, and with credentials. We've already looked at the headers and the params. Now let's go ahead and look at the observe. And if you look down, it says the observed options specify how much of the response to return. So what this means is that whenever we send the request and the response comes back, Angular client look at this option to determine if it's supposed to return HTTP event or the body of the request or the entire HTTP response. By default, it's just going to return the body of the response. So let's go ahead and change this. Let's look at events and response and see what that means. So I'm going to go back to the code. By the way, the HTTP params and the HTTP headers, they're coming from the same library. So they're coming from Angular/common/HTTP. So the same package where the HTTP client is coming from. But for now, let's go ahead and remove those because we're not using them. And I'm also going to remove this option here. And let's go ahead and take a look at the definition again. So if we go inside of this, you can see by default, the observe is set to body, which means that I'm going to copy this. Which means that whenever the response comes back, it's only going to extract the body of the response, which is what it's doing here. It's going to extract the body and then deserialize it to this type or to this shape that we defined here. So we can go ahead and change that. So I'm going to go here and then pass in the observe, and I'm just going to go ahead and change it to something else. So if I do this, so by default, it's already body, but we have a few options that we can pass. And the first one is events. And once I do this, you can see that it's complaining. And if I put my mouse over it, you can see that the type doesn't match anymore because it's returning an HTTP event that's going to eventually resolve to users array. So I can just copy this and paste it here. So what this means is that whenever we send this request, we're going to watch for the HTTP events that are going to come back to us. And eventually this HTTP events inside of it, whenever it's resolved, inside of it's going to have an array of users. So let's go ahead in the browser and let's take a look at this and see what that looks like. So if I go here and then refresh, you can see we have the entire response, okay? Because we don't have anything that takes a lot of time, like we don't have any upload or download or anything like that. So we only get the response back, but I'm going to show you how this is useful because I'm going to show you an example whenever we try to upload files to a server. So we look at this now, we have the entire response coming back to us. And inside of the body, you can see we have our array of users. Okay, so that's the difference between the events and the response. So let's go back to the application. Remember, when you're using the observe HTTP events and you set the report progress to true, that's usually when you're making a request to either upload or download a very large amount of data. So you can see how this was really quick and we didn't really understand what happened here, because it says loaded and it gives you a number and then the type is 3, okay? Which means that there was a type 1, type 2, and type 3. And it happened really, really fast and we didn't even see anything. So I'm gonna show you how you can actually use this in a more useful way. So let's go back to the application and I'm gonna go ahead and define a new function. And this function is gonna upload some files to a server. So let me go ahead and show you what the backend looks like, because you need to understand exactly what kind of response we're expecting whenever we make this request. So I'm gonna open IntelliJ here. So it doesn't necessarily have to be Java, it can be any backend. So if you guys are good with some backend development, server application can be Python or whatever the case might be, then you can set up a backend. But I'm just gonna be using Java in this situation. So this is the application that I have in the backend, and it's gonna take a list of files coming from the request. Okay, so we can make a request to /file/upload and pass in a bunch of files to be uploaded. And this code is very straightforward. So what I'm doing here, I'm getting a directory. In that case, I'm just gonna go to my user home and then go to my downloads. And inside of my downloads, I have another folder called uploads. And that's where I'm gonna save all of the files that I receive. And then this function is gonna take those files, is gonna create a list for all the files names. And then I'm gonna loop through all of the files. I'm gonna get the name of the file, and then I'm gonna define the storage, and then I'm gonna save the file or make a copy of the input stream that I get from the file, and then I'm going to call it replace existing. So if this file was already in that folder, you're just going to go ahead and replace it. And then every time I loop, I'm just going to add those file names inside of my array. And then at the end of it, I just return HTTP response OK, so the 200. And then inside of the body of that response, I pass in the list of all the files or an array of file names. So that's what the backend is going to be doing. And I'm going to go ahead and show you that folder right now. So let's go to my folder. As you can see here, this is the folder. Okay, so you can see I'm inside my downloads and inside of the uploads folder. And the folder is empty right now. I can refresh it. You see there's nothing in there right now. So we're going to save all of our files inside of this folder. So I'm going to go ahead and run that backend server or backend server application or API and let it come up. And this application is listening on port 9000. Okay, so it's running on my local machine and it's listening on port 9000, and we have to send the request to file/upload. Okay, so I'm gonna minimize that for now. So let's just copy one of those functions, and I'm just gonna remove this options for now. And we're gonna define, well, this is gonna return an array of users. We're just gonna leave this function the way it was. And I'm gonna scroll down, and here I'm gonna define another function. So I'm gonna call it, let's call it upload files. And it's gonna take a form data, and I'm gonna show you what that looks like in a second. So let's do form data, and that's gonna be of type form data. And this is gonna return an observable of HTTP events because we want to watch for all the events. And oops, this is supposed to be form data. And this is gonna return an array of string. Okay, so you remember the backend is gonna return a list or an array of string of all of the files that we save, and we have to pass this type as well to the get. Okay, so we're gonna copy this, go in here and pass this type. Okay, this is supposed to be a post request because we're trying to modify some data on the server. I'm gonna change this to a post, and I have an extra and another one here, and then we need to pass the file to the server. So here I'm just gonna say form data. Okay, so let's make sure we understand what's going on here. So I'm making an HTTP request. It's gonna take a form data. Inside that form data, I'm gonna have a lot of files, and then we're gonna call a different API this time. So HTTP :/local host 9000, and we have to go to file/upload. Okay, so this is the URL where we have to pass in this form data. Inside of it, we're gonna have all of our files. And then we're gonna put the option for observe all of the HTTP events, and then report progress. We're gonna set that to true, okay, as our options. So now we have this function that we can use in the component. So let's go into the component, and we're gonna copy this function right here, define another one down there. Oops. And let's call it on upload, let's say upload files. And it's gonna take all of the files that we're gonna pass to the service function. It's gonna be file array, okay? So what we wanna do here, we want to create this form data and then call the service and pass the service the form data. So for debugging, I'm gonna go ahead and log all of the files that I got. And then I'm gonna create a constant, and I'm gonna call it form data and set it equal to a new form data. So the form data is a programmatic representation of a form, and you can set, attribute with it with values. So what we want to do here, we want to loop over all the files that we get and then add them to the form data. So we're gonna say for every file of the file that we got, and we need to define this as a constant. So for every file that we get from the user, we want to add them to the form data. So we're gonna do form data that append, and what we want to do is to pass in the key. So we have to say files because that's what the backend is expecting, and then we're gonna put the files array with the name. So we're gonna pass in that file and then the file name. So we're gonna define that name. Okay, so that's what we're gonna do. So just so you guys can connect this all together, if I go to the backend, you see we're expecting a key files, and this is how the backend is going to be able to extract all of the files that we have and then pass them in as a multi-part file here, which is in Java, but that can be any language that you want, like it can be Python or any PHP backend that you can set up, but in this case I'm using Java. but make sure you put the key for the input as files, because that's what the backend is expecting. And then now we're gonna have this form data, which is gonna be like a form input. And then one of the input is gonna have a name of files, and it's gonna have all of those files inside of it with the key files and then the file name as well. So now that we have the form data, we can call the service and then call upload files. Okay. And then here we're gonna pass in the form data. So whenever we subscribe to this, we're gonna be subscribing to the HTTP event. And if I put my mouse over this, you can see it says HTTP event, and eventually it's gonna be resolved to an array of string as the body whenever we get the response. So that's what this all means, HTTP event string array. Now, I'm just not gonna console log this. I wanna have a way to watch for every event that occurs so that I can do something with it. So I'm gonna put open and close curly braces so that I can have multiple lines, and then I'm gonna go down. And I'm also gonna rename this to events so that we're clear as to what's happening. And then what I wanna do is to switch on those events. So I'm gonna call the switch, and I'm gonna switch on that event, okay? Because I wanna watch for specific events. And then I'm gonna say for whenever this event is of type upload. So I'm going to do HTTP event type that, and you can see I have a bunch of options here. So we have upload and download. So what I want is the upload progress. We can also put the download in there as well. I'm going to copy this and pass it in here and call the download progress. Okay. So whenever this is the case, we want to execute some code. So let's go ahead and just console log that, so that we can see it. And then I'm gonna have another case for whenever I got the response. So I'm gonna copy this, go down, and let's just say whenever this is the response. So here I'm gonna call in the response. Okay, so that means that whenever we get the actual response from the server. In this case, I wanna console log that response as well, or this event. And before we continue, let's make sure we put a break there so that we can separate those. And I'm gonna put another break there as well. And we need to switch on the actual type so that we can get rid of these errors. So what I'm doing here is, I know this is gonna be streaming, so we're gonna get every single event that occurs whenever this method is called. So I'm saying, hey, I'm gonna switch on those HTTP event type. If the type is upload or download, then I'm gonna console log it. If I get the response, then I'm also gonna console log it as well. So now we can call this function and see what happens with this request, and so that we can watch what's going on with those events, because we're gonna be uploading large data that's gonna take time, so that we can see all the progress that's happening whenever we're uploading a large amount of data. And what I wanna do here is to define a form. So I'm gonna define a form, and inside that form, I'm gonna have an input element, and I'm gonna give it a type of file because that's what we're doing. And then we're gonna call our function. So we're gonna watch for whenever this input is changed. So we're gonna call the change event, and we're gonna set this equal to the function that we defined here. So we're gonna go ahead and copy this name, and then go back and pass it here. And this is gonna take the event that occurs whenever there's a change in this input. So we can pass the $ event. And I don't know how familiar you guys are with Angular, but that's how you watch for a change in an input of type file. There's gonna be an event that occurs whenever there's a change in that input. So we're gonna get to the target and pass in all of the files. Okay, so, and I can show you what that looks like. The code is gonna break, but I can show you what this event looks like. So let's remove this for now. And I'm just gonna console log this. So I'm gonna get rid of all of this. I'm just gonna comment it out for now. Oops. Just so you can see what this event looks like. It's not of type file, so I'm gonna put any for now, but we're gonna change this back. So now if we go back to the UI, refresh, we got an error. So we have to close this. This is a self-closing tag, so we have to do this. Okay, so let's go back. All right, so you can see we have this, gonna scroll in a little bit on this. So now we have this input, and when we click it to select the file, that's what the change event is. So that means that the input has changed, and that's gonna fire the function that we define on it. and the function can take the event that occurs if you just pass in the $ event. Okay, and I just want to show you where the files are coming from. And I'm gonna go ahead and select some files, and let's go to this course. So this is all the videos that I prepared for this course so far. So I'm gonna go ahead and select all of them because I want a lot of data or a large amount of file. And well, I can't select all of them. So let's go ahead and change this. Let's add the multiple flag here so that we can select multiple files whenever the window opens. This flag will allow us to select multiple files. So let's go back and let's go here. And it's just gonna select all those videos for this course and select them all, open, and you can see the event. Okay, so this logging is coming from line 82. So if we go back, you can see on line 82, this is where the logging is coming from. That's the event that occurs. Okay, so if we expand this and we go into the target, that's where the input is, and we go into files right here, you can see this is all the files that I just selected. Okay, so those are all the files that we need to send to the backend. Okay, and we can expand to see more information, the name of the file, you know, the size of the file, the type, etc. So we need to take all those files and send them back to the backend inside of a form data. So let's go back and put all this code back. I'm gonna change this. Okay, so put this back. Okay, so we're gonna get files here and also put this back. Okay, so oops. So target files and self-closing tag will take multiple, just like that. Okay, so what's gonna happen is whenever we change this input, which means whenever we click it and select the file, this change is gonna fire and it's gonna call this function. And I just showed you inside of the event target, and then we have an array of files. So we pass in those files to this upload file function, which is gonna be fired here. Okay, so that's gonna call the backend and it's gonna start uploading, and we'll be able to watch all the event type, and then we're gonna log each one of them. So let's go back, and we don't have to call this method up here because we have a call to action on this form, so we can just change the file type or select the file, and then it will just fire this function. So just so we can see everything, I'm just gonna comment out those two so that we only see the logs from the upload files here. So let's go back to the browser and everything is clean, and I'm gonna select a bunch of files. Let me select just a few of them, and you can see everything is happening here. Okay, so you see the event type is now 1. Let's see if we can log the event type again. So here we have log for the event type, which is all ones. Okay, so there's different ones that we can use. So if we go back here, you can see we have response header, which is a different one. We have sent, which is a different one. We're gonna watch for all of those. Okay, but for now we're only interested in the progress and whenever we get the response right here. Okay, so that's why we only have all of the HTTP progress events, so you can see how it's showing us what's being loaded and what the total is. And then ultimately when everything is loaded, the server processes all the files, and then here you can see we get the HTTP response back, and then the last logging for the third callback function that we have here, which is that last one here. So now I should see all those files inside of this folder. Okay, so I'm gonna delete those files because I don't need duplicates of them, but I just wanna show you. Now, what if you wanna show progress, right? You want to show something on the UI, how those files are being uploaded. So you can see that's gonna be very easy to do because we have all of this we can use so that we can show a progress going on. So let's go online and look for some progress bar. So I'm gonna go here and do progress bar HTML, and let's go to W3 and see what we have. So we have this one right here. Okay, so we have this that we can use. So I'm just gonna go ahead and just copy this and go back to the application, and let's go to our component, and I'm just gonna put this like on top of this form right here and see what it looks like. So you can see it's right here. I want to make it a little bit bigger. So I'm going to change the styling a little bit. Just going to put some inline style. We don't need this ID here. So I'm going to pass in style, and let's give it a width, maybe 500 pixel, and then give it a height of maybe, oops, maybe 25 pixel. Okay, let's go ahead and take a look at that. Okay, so that looks better, right? So now what I want to do is to show this dynamic progress whenever the files are being uploaded. So let's go back and we're gonna set our value to this. Okay, so we can bind to this value. As you can see, it's 32. If I change it to 90, you should see this is gonna go all the way up here. Okay, so you can see this is the value or the attribute that is controlling the progress bar here, which is this value here. So we can just bind to this value, and we don't need this 32%. So let's go into the component and let's go down here and let's define some, let's say, file status, and let's set this to an object literal, and let's give it a like a status, and this is gonna be a string. We're gonna start with empty for now, and then we can pass in a percentage, and this is gonna be a number, but we're gonna start with 0. So now we can change the values on this object and then show the progress. So here I'm just gonna copy this, and what I want to do here is, so whenever the file is being uploaded, when we get all of the events here, we can go ahead and change that. Okay, so we can go down here and then call our object, and then we can set the percentage to whatever the event is. Remember, whenever, so let's comment this out for now so that we don't get an error. So whenever we select some files, for instance, oops, you see we have loaded and total. So we can divide these values and then determine the percentage. So let's go ahead and do that. So let's go here, and let's say the percentage is gonna be equal to event.loaded, and then we're gonna divide this by the amount that is the total. So here we're gonna say event.total. So this is gonna give us the percentage of everything that's being uploaded, and then we can get the value here. So let's go and console log that and pass the status here. We can also set the actual status. So we can set this file status that status equal, let's put a string, let's say progress. Okay, so that we know this is progress. And let's copy those two, paste them here. Let's set this to 0 whenever we get the response, and set this to some string like done. And this has to be this. And let's just console log it as well so we can see it. So now if we go back and we select some files and click open, okay, so we can see our status and everything is going. Okay, so you see the status here, we have progress and then loaded, and then oops, the status stays done, so this is incorrect. We can put a check here and say if the event, and we can check the status and see if it equals 200. Then we're gonna do all of this. Okay, so we don't want to do this unless everything is resolved. So I'm gonna move all of this code inside here, and we're still gonna need the break. Okay, so this is only gonna be done, and the percentage is gonna be 0 whenever the response is 200, and then we're done. So let's go back and let's select some files. All right, so we have all the progress, and then we have the done down below, and then the percentage is back to 0. So we can use this so that we can, show the progress on a progress bar here on the UI. So what I'm gonna do is I'm gonna round this up. So I'm gonna do math.round, and then I want to multiply this by 100 so that we can get the percentage. This percentage is gonna be expressed as from 0 to 100. Okay, so let's go. And this is not floor, this is supposed to be round. So let's go and check it out. Select some files, open. You can see now it makes more sense. And we have a typo here. This is supposed to be total. And let's go and take a look. Select some files. Okay, you can see the percentage here. Okay, so we convert this number, we divide them, and then we set it as a percentage, as you can see here. So what we can do is, let's remove this log, remove this log as well. Well, we need this so that we can show the response. So let's put it down below here. And let's try this one more time. Select some files, open. All right, there we go. Okay, so you can see we get all of the event, and then after everything is done, then we get the HTTP response, and then we get our status, which is done, and then the percentage is back to 0. So we can use this to show this progress bar, which is going to be pretty easy. So what we can do is we're going to take this percentage and then bind it to the value here. So we can use property binding just like that, and then pass in the value for this here. And just for sanity check, we're gonna do ng if the status is progress, okay, so that we don't get an error in the browser. And I'm gonna put this on a separate line. Okay, so we're gonna show this value as a percentage. So now it doesn't show because we don't have anything going on here. So now if I select some files, upload, you can see the progress, okay? Boom, when it's done, because it's gone because the status is done, it's no longer a progress. And you can see here. Now, if you want to see it more, that means we have to select more files. So let's go ahead and select all of those files and let's do open. As you can see here, we have a very nice progress bar, and you can see the percentage here as well that we're console logging. So that was more Angular than just the HTTP, but this is a very crucial part of the HTTP client whenever you're using it to make requests. Because if you're building an application, chances are you might have to upload files, and you might have to show something to the user so that they understand there is something going on. So that's how you would do this. Again, there are different ways you can do this. You don't necessarily have to use a switch here. Like you can use if statement, but I like to use a switch because I think it's a little bit cleaner. But you can use if statement, and you can change whatever you want here as long as you can make this work. So again, if we select all those files, open, oops, it's the same file, so we have to refresh. There was no change event that was registered because we selected all those 33 files before. So let's go ahead and select those files, select all of them, open, and you can see this is our nice UI that we've built. So you guys can take this further, like if you want to build your application, this always works, so it's always going to work. And this is how important that those flags are. Okay, so if we don't set this, it's not going to work. Okay, we're not going to be notified of the HTTP event, and we're going to get an error if we're trying to return HTTP events here. Okay, so again, if we look at the status, you can see inside of the body, we have all the name of the 33 files, which is an array of string, as you can see here. So this is how you would use those flags if you try to do some upload or download. And again, if you look here, we can also set the download progress, and it's pretty much the same thing in case you're downloaded some file. You can do the same and then just look at the download event, and then you can do whatever UI manipulation that you want to do. So that's just one example I wanted to show you guys, because I know this has been a question on the internet, because I was looking at this like a few years back, and I was like, oh, okay, this is pretty easy. So this is how you do this. So you can use this in your application, and it's very nice user experience, and you can use Bootstrap or whatever UI you want. You don't have to use this this basic progress bar. So I'll see you guys in the next one. So far, we've looked at almost all of those options that you see here, and we have to look at the response type and the with credentials. So let's go ahead and look at those. So I'm going to go back in the code, and let's just take a look here and see what we have. If I do Alt F12, you can see that we can pass in the response type. By default, it's JSON. So that's why everything's been working, because we just deserialize everything as JSON. But that's not always the case. So most of the time it's going to be JSON with the new API and RESTful API. They usually return JSON, but sometimes you might return a different data type. And as you can see here, this can be an array buffer, a blob, or JSON, or text. Okay. So you usually have blob or array buffer when you're doing some kind of a download and you're trying to buffer some bytes. Okay. And that's the same for blob as well. You can use either depending on the type of download that you're doing. And then JSON, we already talked about it. Most of the APIs, they use JSON, but you can also get text. So I'm going to show you 2 examples of the array buffer or blob, and then the text, because we've already been doing the JSON, which is the default, and pretty much almost all of the functions like the get, the put, and all the different variations of them. So let's go ahead and see what we can do here. So I'm gonna copy this, and let's just go and paste it up here. And let's say I'm gonna call this get text file or something, because I want to show you an example with the response type text. I'm gonna remove the observable for now so that we can determine what the response is going to be. And then here, let's see, let's go into the asset folder here, and I'm gonna put a file here, and I'm gonna call it file.txt. Okay, and I'm just gonna, oh, I already had one here. Oh, okay, so I had one here already, so I'm just gonna delete this. All right, so I have this, I remember that I just put this in here earlier. So we have this text.txt file, so we can make a HTTP request to read this file, and that's when we're gonna set the type to text and not JSON, because that's what this is. So let's go ahead and close this and collapse this. So we want to send this request to assets, and this was text.txt. Was it text? It's text. Yep, text.txt. Okay, so that's that. So we're gonna get text file, and if you hover over this, you see it's returning an observable of user. So let's remove this. All right, and then pass in the response type in our options. So here I'm gonna do response type and set this to a string, and I'm gonna do text. Okay, so now Angular is smart to read this value that we're setting here. So let's see the response type now. You can see it's an observable of string. So we can just pass this in as the response type that we're gonna get. So here, I'm gonna say this is an observable of string. Don't forget the colon, and we can pass in the same type here. Okay, just to be consistent. All right, so you see, oops. So it doesn't take the type. Okay, so the way you can determine how this thing works is this way, because I used to have problem with this. Like I would do something like this, like I would know exactly what my HTTP call is going to return, and I put in the appropriate option, and then it will give me this error. So this is what you do when that happens. You remove the type in the get or the put or whatever the method is, and then you go inside of it. So I do Alt F12. So you see here, it's not a generic. You see, it doesn't take any generic. So whenever the response type is text, you know it's going to return an observable of text, but you don't have to specify anything here. Just leave it blank, okay? Which is why it was giving us an error, because we actually have the definition for when the response type is of type text, okay? So that's the case here. So we just leave this blank because that's how it's defined, and then it knows that it's going to return an observable of text because we specified this here. So let's go ahead and call this function get text file. Let's go and do the component, and just gonna copy this, and let's just paste it down on get text file, and we're just gonna call the get text file. Just pass it here. It doesn't take any parameters. Okay, done getting text file. I'm just gonna remove this. All right, so now we can read whatever the response is, it will show here. So let's call this function, and let's go up here, and let's just call it here. So now let's go to the browser and go to our application. You can see it's already here. Okay, so if I refresh, you can see this is the text that we have. So that's how you read text if you know that your response is gonna be of type text. And I'm just using a text file, but sometimes you can have like an actual backend and they just return like text instead of like JSON or anything else. So you can see if I change this or if I don't pass it, okay, by default it's gonna be JSON, and now it's gonna ask me to define this. Or what I can do is I can just leave this out so that it doesn't complain, okay? So it knows it's gonna return an observable of object or whatever the case. So now if we go back, we get this, and it's an error here that we get, okay? It cannot read the syntax because it thinks it's JSON. When it tries to read it, you can't read it because it's not JSON, okay? So we get this error here, and the HTTP response here, we have an error. So if I refresh again, you can see we didn't read it properly. We did get a 200, but we didn't get the data back. You can see instead of a response body, we get an error response. And whenever you get this unexpected token, there's something with the JSON. So it couldn't read the JSON. So let's go back and change this to response type text. So now even if we remove this, because we pass in the response type, you'll be able to read it. And there you go. Okay. And if we had the case for like array buffer, so you would have something like this. So you would have blob, for instance, and then your request might look something like this. So you can have, let's see here, and then you would have the HTTP response, and then you pass in the type. And here you would say blob. And now we have too many of those. All right, so it would look something like this. And now we have to pass in this option because this is expecting an HTTP response. So here we can pass in the type for blob, and then we pass in the observe, and we're gonna say response. Once we do that, it doesn't complain anymore. So something like if a request to download some information, it could look like this. So we know it's gonna return an HTTP response. Instead of the body of the HTTP response, it's gonna be blob information or some binary data, and then we make our call or whatever, and then we set the response type of type blob. Okay, so I have other courses where I show how to download information, and whenever you creating the HTTP request, it's gonna look like something like this. So I just wanted to show you guys the different response type, but I don't have an example backend that I can show you for download, but that's what the function would look like if you were to like download file something. Say download file. Okay, oops, like get download file. It would look like this. So that's pretty much everything for the HTTP request. Again, that's the basic, and I'm going to show you a more reactive way to make HTTP requests instead of this procedural way that we have here when we declare function and then we call those functions. In this section, I'm going to show you how we can manipulate the data that we get from the response. So you see that we're making HTTP requests, and then we get the response back, and then we pass that response over to the component. And then we can show it in the UI or console log it as we've been doing so far. But there's also a way that we can take that data that we get back, so the response that comes back from the server, and then manipulate it in some way before we actually send it over to the app component. But before we dive into the code, it's important that you understand the concept of reactive programming, because that's what we've been doing so far, even though I haven't explicitly mentioned that some of this code is actually reactive. So you can see here, we're making some HTTP requests, right? And then we're subscribing to the response, as you can see here, we've been doing with those methods. So whenever this code, for instance, this get user, whenever this code execute, it actually goes and go from line 43 to line 49 and then move on to the next line. However, until the response comes back, these lines of code, these 3 lines of code, they're not executed unless the response comes back, which means this is reactive. It means that whenever the response comes back, this code by itself, it just runs, because that's just how reactive programming works. So before we can go and look at how we can actually like modify the data whenever the data is returned to us or whenever the HTTP response comes back, we need to understand a little bit of reactive programming and RxJS. As you can see here, we've been using RxJS here. You can see RxJS, which is reactive extension for JavaScript. So I haven't really talked about that. But before we can actually look at some of the ways that we can manipulate the data or the HTTP response, and then before we send it over to the component, we actually have to understand a little bit about reactive programming. So I'm gonna go ahead and go over some slides and then give you an overview of reactive programming, and we'll also get an overview of the RxJS library that we've already been using and how we're gonna use this library and some of the functions that it has so that we can manipulate the data. And I'm also going to show you how useful this is, because sometimes what happens is you want to manipulate the data in some way before you actually send it over to the component so that the component can expose that data on some UI or something. So let's go ahead and take a look at this. So the first question we want to answer is, what exactly is reactive programming? So whenever we make an HTTP call, we have to subscribe. And then whenever the response comes back, then our subscription or the code where we have the subscription, in this case where we're console logging the information, this code executes. So that's exactly what reactive programming. It means that it can react to some data stream whenever the data is actually there. In this case, whenever this data is emitted. So that means that we can have some piece of code and we know that it's going to react to some changes later. In this case, whenever we have some data stream that we're expecting and this data or this data stream is there. So the role of the observable that we've been using is to just emit this data to all the observer. And one of the observers in our case was the component that we had, which is why we subscribe to that observable, because we want that observable to propagate this change in data or this stream of data over to us. So that's reactive programming. So it's a little bit more complicated than that. And reactive programming deserves a course for itself, but I just want to give you a high-level overview of exactly what that is, so that you better understand later when we start using some of the operators that we're going to use. So reactive programming, it's going to run in a way that it's going to wait for some changes to happen, and then this change is going to propagate like down a chain of observers, if you will. And you usually use this type of programming when you're dealing with asynchronous data stream. Hopefully by now you guys understand when people say asynchronous, it means that it's not gonna happen at the same time as something else. That's the meaning of the word. But in programming, what that means is that you have some piece of code and it's definitely gonna run by itself at some point in time, and it's gonna react to some changes that's gonna happen. And that's usually some data stream. And a very perfect example, which is why it's being used in RxJS and which is why it's being used in Angular, is when you're making an HTTP call. Because we know that whenever you make an HTTP request, unfortunately, you have to wait because there's a whole network that the request has to go through routers and wires, and maybe it's propagating in the air or whatever. And then it has to go to that specific host where the data is. So all this data that we've been using, this data is somewhere on some server or some computer on some network that can be like very, very far away. So whenever we make a request to get this data, it's going to take some time. So we have to create some reactive way so that our code can react whenever this response comes back. So if we send a request over to the server, we know it's going to take some time, but we need to have a way to, get that data or be notified whenever this data is back. And we want to continue running the code because we don't want to stop the code or stop the execution of the program and then wait for the data to come back. That would be like a horrible user experience. So the whole point of creating this type of programming is to come up with a way to make the user experience better. So we're gonna go ahead and run the code, and it's gonna run from top to bottom. But because this code is reactive, it's not gonna block, which means it's asynchronous. So it's gonna happen at a different time or at a later time. And then the code is gonna run. So whatever code that we have, it's gonna run from top to bottom. However, whenever the response comes back, the code is gonna react, which is the reactive part of the reactive programming. And that's what we've been doing with the observable. The observable class that we've been using that I just showed you earlier is just the emitter. So whenever the reaction happens, which means whenever the response comes back, then the observable emits the data, in this case, the HTTP response. And another way to look at it is, you remember in our service, we are waiting for some data. So we need some data that we need in the component, and we want that data to, show some users or something. So the data is gonna come in the service. So whenever the HTTP response comes back, that's the reaction that happens, right? So you can think of this as the reaction in the reactive programming. And then what the observable is gonna do is it's gonna take that data and then emit it. So if we were to show this in a more visual way, so it would be like this. So we have the reaction, which is the HTTP response. And then we have the observable. The observable is the emitter. So it's like it's the guy that's gonna tell everyone, hey, we get some data. So whenever the data comes back, so whenever we get the HTTP response, it's gonna go into the observable, and then the observable is gonna just emit this to our observer. And in that case, that's gonna be our component. And then from this point on, we'll be notified, and then we'll show the data done to the user. And usually might have something like some loading spinner or something to indicate to the user there's work being done in the backend, and they just have to wait for some data to come. So you can visualize this way. So you have a reaction, and then whenever this reaction occurs, then you have an observable, and that observable just emits the data to all the observers. And this will bring us to RxJS, which we're gonna look at next. So now let's look at RxJS. So RxJS is really just a JavaScript library that you can use to create reactive programming. So if you want your code to be reactive, in this case, we want whenever there's an HTTP response, we want our code to react, so we want something to happen, then you can use RxJS to make this happen or to code in a reactive way. So RxJS is really packaged with Angular. So whenever you create an Angular application, it comes by default with the RxJS library. That's how dependent Angular is on RxJS. The observable class that we've been using, it's coming from RxJS, like I just showed you in the import. For our data manipulation, we're gonna be looking at some of the RxJS operators. So right now on the screen, I have some of the operators that are most relevant to the Angular application or to the Angular HTTP. So whenever you're gonna be doing some data manipulation, mostly with Angular, that's not the only way to do this, but mostly with Angular, it's gonna be with some HTTP response or some data stream or something. And some of the most common operators that you would use with RxJS and Angular are those that you're looking at your screen right now. So we're gonna be looking at some of those because they're really, I really have to like make a course, especially on RxJS operators and observables and data stream and stuff. But because we have to do data manipulation, we really need to understand reactive programming a little bit and then understand how this whole thing works. So I'm gonna be using maybe like a couple of those operators, but then I'm gonna show you the website where you can go to explore more if you are really interested in understanding RxJS operators. But for what we're gonna try to accomplish in this section, we're just gonna look at 3 or 4 of those operators, and then I'll show you how you can manipulate the data in a reactive way, which means whenever the data comes back, so that you can change the data in whatever way that you want or however you want to display it to your users. So this is the RxJS website, and as you can see here, it says it's a library for composing a synchronous and event-based program by using observable sequences. So what this means is that we're going to create asynchronous code, which means code that's not going to block the execution of the program, and they're going to fire based on certain event. In our case, that's the HTTP response. Whenever we receive something, then something is going to happen or a reaction is going to happen because that's some kind of event. And what I want to show you on this website is the operators. So let's go and click on operators. And as you can see here, this is a very long list of different types of operators that we can use in our program. But you can go ahead and check this out. It's really a lot, so I can't really go over all of them. And we really would need to have like a separate course on RxJS so that I can show you what those can do and how powerful those things are. But we're going to use some of them, some of the operators, and then I'm going to show you how we're going to manipulate the data before we send it over to the component. So let's go ahead and go into code and start playing with those. So the first operator that we're going to look at is the Tap Operator. So what I'm going to do is I'm going to move those functions down so that you guys can still have them as reference. And I'm going to use the get users to get all of the users and then use it to show you some data manipulation. But we can use any one of those functions here. So let's take a look at the Tap Operator and see how we can use it. So let's go into the documentation to know what exactly is the Tap Operator. So I'm on the website and you can see here it says the Tap Operator perform a side effect for every emission on the source observable, but return an observable that is identical to the source. Which means the Tap Operator is going to take an observable and we can maybe like look at this observable and then it's going to return an observable that's identical to the source observable. And you usually use the Tap Operator so that you can take a look at the data to see if you're getting exactly what you're getting and things like that. It's used for debugging, so it's more like a console log kind of thing, but you can use it for other things as well. So let's go ahead and take a look at the Tap Operator. So let's say I want to take a look at the data using the Tap Operator, in this case on the get users function. So before you can use any operator, you have to call the pipe function. So we're going to do pipe. And what this is going to do is it's going to put all of the operators together. So whenever you need to use any operators, you have to call the pipe function and then pass in the operator in there that's going to take your observable. And that's just how it works. You have to call the pipe function so that you can kind of like lump together all of the function that's going to take and return an observable. So here what we can do is inside of the pipe function we can call tap. So we're going to say tap, open and close parentheses, and we have to import that. This is supposed to come from RxJS operators. And you can see here I have the Tap Operator and it's coming from RxJS/operators. So now what I can do is, remember, this is gonna take the incoming observable, right? Or the source observable. So what I can do is I can just call it users, because I know it's gonna be an array of users. And then I can do something with this users before I actually return it. So let's say we wanna just console.log this information, and then we're gonna say users. Okay, so that's how you use the tab operator. You can just tap into the data to take a look at it, if you want to. So now if we go, let's make sure this application is running. Check the terminal. All right, so the application is running. And all right, so let's go ahead and check it in the browser. So now we have to go ahead and call this function. So let's go into the component and let's comment out the one that's getting the text file. And then we're gonna call get users. So on get users. So now if we go back to the browser, so we see we have two logs. So we have one coming from the user service on line 18, and then we have another one coming on line 37, which is the one in the component. So you can see how we can tap inside of this response or this observable and then take a look at it. But that's just the tab operator. Usually use it to look into the data, maybe check for some values, and then maybe tick a different logic. But you can just look at the data and it's going to return the exact observable that it got as a source. So now let's go ahead and look at the map operator. So before we go look at the map operator, I want to show you guys the changes that I made in our application so that we can stop looking at stuff from the console here. So I'm showing all of the users here on the table, and I'm going to show you those changes that I made in the application. But you should be able to get the source code and the lecture so that you can follow along with this. So we can still see what's going on in the log in case we have to look at this again, but we can stop looking at this for now and then just look at the UI so that we can see what we're doing better. So I'm going to collapse this for now, and then I'm going to show you what I did. It's very simple. I just in the component I defined this new users field, and I set it as an array of users, and then down below where I'm getting all the users, I just set that users to the response. Okay, and then in the component I have some basic bootstrap styling, and then I have a table, and then here I just loop over all of the users, and then I show some of the information, and it looks like this. Okay, so all right, so now let's say I'm just gonna try to come up with some scenario, but you looking at this, you will be able to to say, hey, I think I can use this in my project for this or a specific feature or something. But I'm just gonna show you some examples as to what we can do to manipulate the data and then change the data in some way. So we're looking at this list of users, and this list is coming from a backend API, which means we don't really have a lot of power over changing this data, because we don't own this data. We're calling some API, and then we're showing this data like this. So let's imagine your client or whatever, they come to you and then they say, hey, we want to have all of the first name uppercase, right? We know we can't change the data in the backend, but is there a way we can do that in the front end? And yes, you can do that in the front end using the map operator. Now, there are other ways to do it as well. You don't have to use RxJS and the with the map operator and all that stuff to do this. You can just get all the users in the component and then run them through some array or something, add some logic, and then change this. So there are many other ways you can achieve the same thing, but I'm going to show you how it's usually done. Whenever you're working with the Angular HTTP and you're making requests, then you can just change the data as soon as you get it, even before you send it over to the component. So let's go back to the application, and we want to go to the service. Now let's say we want to map this data to something else, right? Let's say we're going to put all the name to uppercase. So we can use the map operator inside of this function to do that as well, so that we can manipulate the data in that way. So to pipe in another operator, you just put a comma, and then you put the name of the operator, and then you work with the operator there. And we're gonna import this as well. It's supposed to come from the same library, so RxJS operators. So the map is gonna take the source observable. In that case, we're gonna call it users, because we know we're getting a bunch of users. And then here, what I wanna do is I wanna put my transformation. Okay, so if you wanna learn more about the map operator and how it works, you have to go here, okay? Because this is like a whole explanation that I have to do, but I'm just gonna show you how you can use it really quickly. And then maybe later, after you watch this lecture, then you can go ahead and look into it some more. but let's just go ahead and use it. So here, let's say I want to take these users and then make all of the names uppercase and then send that over to the component. So we're going to use the map operator so that we can do this. And then what we can do is we can take all those users and then map over them again. So here we're calling the JavaScript map because we know this is an array, and this right here is more like an observable, as you can see here. But then here we're calling the arrays on in JavaScript. Whenever you have some array, then you can call the map on that specific array, or the map function. And then here, what we want to do when we map all of those users is to change the information that we want to take. So we're going to say for every user in that map, whenever we're mapping on the array, we want to execute some code. So we're going to do something like this and then run our code here. So what I want to do is I want to take everything in the existing user and only change the name. So what I can do is I can do something like this. So I'm going to say I want to return a new object just like that. And then what I want to do is copy everything else that I already have on that object. So I can use the spread operator here and then do something like this. So I can say, hey, give me everything on that user. And then I'm going to add in some more. But this time, I'm not really going to add something. I'm just going to override an existing property on that object. So what I'm going to do is I'm going to say add another property, which is name. But since name already exists, it's just going to go ahead and override it. And I can say for that user, get the name of that user. And then since it's a string, then I can call to uppercase on it. So you can see how I can use the map operator, which is being used here. Forget about the tab for a second. I can comment this out just so you can focus on the map operator. It's a little bit tricky because we're using map here, and then again we're using map here, and this is a little bit tricky sometimes because they have the same name but they're two different functions. Actually, this map operator from RxJS, it's built using this map here a little bit, but they're a little bit different. But if you look at the documentation, you'll see that a lot of those operators, they're built upon existing functions that you have on array, like filter, at least the transforming RxJS operators. But anyway, so here we're mapping the users. Now remember, this is one event, which is to say that whenever the HTTP response resolve, it's gonna emit once. Even though it's a list or an array of users, it's only gonna emit once, which is the HTTP response. So that's not gonna happen multiple times. So we're gonna take this observable and then say, hey, we're gonna do some logic with it, which is gonna happen from after this arrow here. So we're gonna say, take this array and then map every value in that array, oops, and then use every user inside of it to copy every existing attributes that they have. So we're using the spread operator, and then we're gonna set a new one, which is the name. But since the name already exists on this object, it's just gonna go ahead and override it. And then we're just taking the name and then turn it to uppercase. So now if we go back, you'll see that all the names are uppercase. So you can see already how powerful the map operator is, because we can literally like manipulate the data in any way, shape, or form that we want. Another thing we can do with the map operator to transform this data is that we can add attributes that don't even exist on the data itself whenever it comes to us. So let's say that we want to add some more attribute to this. Let's say we want to add some admin information. So we want to check to see if the user is admin or not. So I'm just gonna, do some random example here. So let's say we want to add a new attribute to see if the user is admin. So we can do something like this. We can put a comma and then we can say is admin, okay? And you can set this to either true or false or whatever the case might be. But let's say you wanna maybe like check for the ID or something. So you can say like user ID equals 10, something like that. And then if that's the case, then we're gonna say let's say true, right? We're gonna say true. Otherwise, we're gonna say false. Oops. We're gonna say false, okay? So that's technically valid. And even though we don't have this is admin on the user, TypeScript is not complaining because at least we have all the properties that exist on that user. We're just adding some more. So now, well, we have to actually display this now. So if we go to the here and let's just copy the email and then paste it down, and let's say role, for instance, right? And then after this, the email, we can copy this and say user is admin. So now, even though we didn't have this property coming to us from the backend, we still manipulate the data somehow, and then we add this new property, and then we use some logic to set it. Obviously, this is like a dummy example, but you can think of whatever you want, and then set this to true or false. So now if we go, you can see false, 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 but then the last user ID is 10, and then this is true. And you can set this to a string as well. Like you can do something like, if that's the case, then set admin, otherwise some user or something, and that would work as well. Now another example I want to show you is, what if you don't want all those properties? So as you can see on that list, you see that if we inspect this, let's go to the console, and you see we have company and then we have address, right? So let's say we didn't care about the company and we didn't care about the address. We just want the email ID and all the other stuff. We don't want the company and we don't want the address. I'm just taking those at random. It's not because they're object. But let's say for some reason you didn't want to map the address and the company into your your data, because you know what you're getting, but you don't want everything. So let's see. So what we can do is, first of all, we can go inside of the user class. We can just remove those altogether, or we make them optional so that TypeScript doesn't yell at us when it doesn't see the company and the address. Okay, so we say, hey, this is optional on that specific shape. Okay, so whoever is going to define some piece of data by that shape or by this interface, the fact that they need to add an address and a company is optional. They can leave it out, and I'm not going to yell at them or give them an error or anything like that. So that's step one. You make those optional. So then this will require us to map everything inside of that object. So we can set the name like this, and then set is admin, and we can continue and then add all the other information that we want. So for instance, let's say we want the email. So we're gonna say email equals user.email. Let's say we want the website. Let's say website, and then we say user.website. And it's complaining because we still have to add some more of our properties. So let's see what we need to add here. So username, phone. So let's add the phone. So let's say phone, and they have to be they have the same name. So the key has to be the same. And I think we need to add the username. Did we add that? Nope. So username, and then user.username. And we need to put this here. So now you can see that we reshape this data that we're getting, and we're getting rid of the company and the address. So now if we go back, you can see, if we look at this, now we have a cleaner object. You see, there's no company, there's no address or anything like that. We reshape the data to something completely different. And we can do the same for all the other functions. So let's say this get user here, we want to maybe like map this user to something else. We can just use the map again and then just go straight into this. So we can skip this part because we don't have to do it for every single item inside of that array. So it's gonna literally be the same thing. There's another example I want to show you, like a really cool example. So we're going to look at that next. What I want to show you next is how you can add an image to those users as their default image. As you can see, whenever this data comes back to us, we don't get an image for those users or anything like that. So maybe we want to show some default image for the user or profile image until the users can actually go into the system and then update their picture. So I'm going to be using this API called RoboHash. And what it does is you give it any string and it's going to generate some random picture of a robot. So for instance, if I go here and then I say user and then press enter. Oops, maybe I already did that. So let me refresh. You see the picture is different. So now if I say something like user enter, and then you see it gives me a different picture. So for whatever like string you give it, it's gonna give you a different picture. So let's say we wanna use this and then generate some random pictures like you can see here, and then give them to the user at random. And then later, well, maybe you might not wanna give them that one. And then later they can come in and then change their information. And this is something that happens a lot. So let's go ahead and copy this URL. And let's say we go into the application, and I'm gonna just define it on top here. I can define it as a read-only, and let's say this is the default image, and then we're gonna set this to the string, just like that. Okay, so now we can, well, I don't think I need this. So read-only, and it's gonna be here, so that we can't change this value later. So now what we can do is we can just add it to this as a new attribute to this object. We can either go in here and create another, let's say, this is a string, and this is something like image, and we can just use that, or we can just add one directly here and it's still gonna work. Okay, so but we can do it that way as well. We can define this image, which is optional because we know sometimes we're not gonna have it, and then we can just set it by some default image. So here I can just say image because that exists. Oops, not this image, and then set this equal to whatever value that we want. So remember, we call this image, so the name has to be the same. If we pass in something else, then it's just gonna add it to that object. If you put in the same attribute that already exists, it's just gonna override it. As you can see, we're doing with the name, username. We don't have two username or two name. It's just gonna override it. So let's say here, what we want to do is we wanna call this, let's say we say, we're gonna call our string. So we're gonna say this, and we want the default image, and then we're gonna add in the username inside of that as well. And then we can do / and then we need to get the user. So whatever user, get their username, and we have to put this to lowercase, otherwise it won't work. It has to be lowercase, and then pass it like this. So you can see we're passing in a new attribute to this user, and that's their image. Okay, and then we can use that in the UI so that we can show the image of the user by just using this right here. So we can go into the component, and I already had something for the image, which is I think right here. So I'm gonna uncomment that. Oops. Go here and uncomment that, and that's gonna be their picture, and then I think it's right here. So I can just uncomment this. Okay, and that's gonna be just the image. Earlier I named it image URL. Okay, so that way we have a picture for the user, and then we just bind it to the source attribute on that img tag. So now if we go back, and we don't see the pictures, so let's go back. Oops, this is image URL, so this is supposed to be image. All right, just like that, because that's the property that we have defined here. You can see image, so it has to match image, and then we go back. You can see now they all have some random robot image here. So you can see how you can take some plain data and then manipulate it, make it a lot more interesting, and you can do like all kinds of things with this. So I hope that was helpful to you, and I'll see you in the next one. So let's go back to the service, and so this is for when you're dealing with some array of data that comes into the body. Remember, you have to map it twice, so you have to use the map operator and then change the data in any way, shape, or form that you want. So let me show you how you can do this for like a single item that's not like a collection in the response body. So let's say we want to take this user and then maybe do some manipulation like we're doing here, but in this case it's not an array, it's just a simple user. So what we can do, we can of course call the pipe, because that's the operator that you call before you call any operator, and all other operators are gonna go inside of that one. And then we're gonna say map, and we're gonna name this user, which is the intake observable, or the source observable is gonna pass their observable to this map observable. In this case, we know we're gonna get a user. And how do we know that? Because we know this get is gonna return a user because we're deserializing this in the request. Okay, so we know we're gonna get a user. And then what we can do here is we can just return a new object of that user. So we're gonna do something like this. And then here we're just gonna say return and then a new object. And then again, we're gonna copy everything else from that user. And then after that, we can put everything else that we want. So for instance, I can put another attribute like, let's say is admin, which we've used before. And then I can set this to true or something. So this is how you would do it for like a single item inside of the HTTP response and not a collection. And this can be anything, like you can pass in any data type that you want here. So for instance, you can pass in an array. So like you don't have to pass in like a single simple data type. So let's say there's like a search key, for instance, right? So there's a way that you can search the users, and by default, whenever we get this list of users, we want to set some key. So we can just say, hey, this is an array, and let's say the first element is like the user dot name, and then the second element is the user dot username or something. Okay, that will work as well. Like we created this search key, and then we pass in those values as initial values or whatever like string that we want to pass in here, or any number or anything. And we can do the same here as well. So we can say, hey, this guy's an admin and their search key is this right here. So let's go into the component, and on get user, we have to call that now. So get user, so that we can see something in the UI. And then here, this is gonna look exactly the same, but then if we check the console, and this is the second object, so you can see the user that one user that we set the search key for, is admin, is now true. And then in our list of users, you know, we'll have the search key as well, which is like an array with 2 elements in it, and we can, you know, do any manipulation that we want. That's just what I wanted to show you guys, you know, as far as like operators are concerned. And this is really very basic. This is the operators. There's a lot of them, and here we only looked at, like, barely looked at 2 of them. So the tap operator that you usually use for debugging, and the map operator that you use for transforming the data. But there are other operators that you can use to change the data, and we're gonna look at some more later when we're gonna do some more advanced HTTP request stuff. But for now, I just wanted to show you that you can actually manipulate the data like in an amazing way, even before you send that data over to your observers. In that case, that was one observer that we have, which is the component, because it's the only component that's like watching or registered or subscribed to this observables that we have in this function. The last operator that I want to show you is the retry operator. So let's go into the application. So let me put this tap operator back, and let's say we want to make this HTTP calls at least a number of times. If it fails, before we can consider it failed. So there's another operator that we can put in here. It's called retry. So we can do, well, before I do that, let me just copy this function, and I'm just gonna go ahead and place it down there and then comment it out. Okay, so you guys can have it for your reference, and I'm not gonna map this anymore. So I'm gonna remove like those operators, and what I want to do here is call retry. Okay, so we're gonna do retry, and that takes how many times we want to retry. So say we want to retry like 3 times. Okay, you don't want to retry like 10 or 20 times. And let's add this in our operator list. Okay, so all of those are coming from the same package, RxJS operator. So what this is gonna do is it's gonna retry this HTTP call 3 times before it fails. So let's say in our URL, let's make this fail. Let me put plus, well, I don't have to do it like that. Let's say I put some zeros in the end. Okay, so this is now the, you know, URL is incorrect or invalid. So what this is gonna do is it's gonna call this API 3 times before it fails, okay? Because that's what we're specifying here. We're gonna retry 3 times. After that, we're gonna fail. So if we go back here, well, obviously we have no users. Go here, now I'm gonna clear and refresh. You see we have to call 3 times. So we have 1, 2, 3, and then eventually it fails, okay? And this is the logging for when we get 1 user that the example that we did earlier. But you can see that we got 3 times in addition to the initial call. So there's 1 call. Remember, this is a retry. So we're going to try it again after the first one. So the first one fails, as you can see here. Then the second function runs. Then we get the logging here. And then we get 3 retries, as you can see here. So we tried 3 more times after the initial one. And then it fails for good down there where we're console logging the HTTP error because this is an invalid URL, as you can see here. So the retry is really very like important. You can use it in many applications, and you know, try the request a couple more times before you actually accept the failure. But just make sure you don't put a high number there, because if you do that, then you're just gonna be flooding the backend, and that can cause some performance issue. So make sure you keep it low. So I would say like maybe like, you know, 2, 3, 4, but not like 20 or something like that, because that's gonna be like too much for the backend. You're just gonna be wasting bandwidth on your network, and it's just gonna fail. So usually, if something is up the first time, it should work. Or the second, if it's something that's really important, then you can go 3, 4 times, but not 10, 20, 15. So just be mindful of that. But that's the retry. It's also very important. There's another one we can use called share replay, and this is used to cache information. But the thing is, when you cache the information, it's cached indefinitely. So, you know, I usually don't like to use it, but that's another one that just came to my mind. It's called share replay. You just put it here and you pass it how many observables it needs to replay. In that case, that would be just 1, because when you make an HTTP request, the observable only emits once, even though the HTTP request body can have like a collection of like a million users or something like that. But it's gonna emit once because it's only emitting the HTTP response, which is one event. Okay, so just make sure you understand this. So I wanted to prepare you for using these operators because we're gonna jump into error handling, which we're not doing here. And it's really important that you have some basic knowledge of like observables and some of the operators that you can use here, passing in the pipe, and call whatever operator that you need to use. So I'll see you guys in the next one. In this section, we're going to start looking at error handling. Now, this is very important because whenever you make an HTTP request, there are so many things that can go wrong, and you want to make sure that if your call fails, then you handle all errors properly. So this actually is super important whenever you're using the HTTP to make requests over the internet, because you're gonna make an HTTP call, the server can be down, you might have some network problems. So there are many different things that can go wrong. So you want to make sure that if there's an error, then the observable will just spit out an error to you. So you have to make sure that you have proper error handling in your application so that you can either show some message to the user or take an appropriate action, or you can even send a different data to the user. So if you try to fetch some information and you can't find it, then maybe you can return some local data or something like that, which we're going to take a look at in a second. So whenever there's an error in the observable, when you make an HTTP request, the observable is going to stop. So it's not going to emit anything anymore. It's going to stop emitting, and it's just going to stop. And you won't be able to use that observable anymore because it's not going to emit. There's no data. It's just going to give you an error. So that's the first thing you really need to understand. If there's an error, the observable is going to stop. It's going to stop emitting, and you won't be able to use that observable anymore because an error occurred. Now, there are two ways that developers usually use whenever they're dealing with errors. So they can either catch the error and then rethrow it. So they can take the error, maybe they can manipulate it in some way, and then throw the error again to the application or throw it down the line. Or, like I just mentioned, they can catch the error and then replace the error with some default data or some default message so that the user in the front end understands that something just happened and that's why they're getting this type of data. So for instance, you might be fetching some users and you can't find any users, and then you send a default user or something like that. Or you can catch the error in the case of catch and rethrow, and then you just rethrow some strange, or you look into the error before you rethrow it, and then you determine what the cause is, and then you show an appropriate message to the user. So it's really going to come down to how you want to design your application, what are the requirements and things like that. But usually there are two main approaches: the catch and rethrow. When you catch it, rethrow it, you can manipulate it before you rethrow it, or you catch it and then replace it. In the case, for instance, if we're fetching a bunch of users, then we can't find them from the remote server, then we can just use some local data or something like that. So in the next lecture, we're going to start looking at both catch and rethrow and catch and replace, and then we're going to look at some examples. So the first approach that we're going to look at is the catch and replace. Now we're going to take a quick example in our service. So remember, we have our user service, and then we have this function where we try to fetch some users. Now let's say for some reason this call fails and then we get an error. In that case, we're going to use the pipe operator and then the catch error. And then in here, we can pass in the error, we can console log it. And then instead of rethrowing the error, we just return some observable of some data. In this case, I'm returning an observable that's going to be a simple user with an ID of 0 and the name of John Doe. Now I'm just returning this observable, but you can return whatever you want. It doesn't even necessarily have to be anything. You can return an observable of nothing. And what's going to happen is in your component, the error function will never be called. So you can see that when we subscribe, we have the response and then the error and then the completion function that doesn't take any parameter. So the one in the middle, so the error, will never be called. Instead, when an error occurs in the service, it's gonna just return the observable that I'm passing where I'm catching the error. And then it's gonna just spit that out to the component, and the component is just gonna read it as an array of users, as you can see I'm doing here. So if there's an error, the response is going to be the name of John Doe and the ID of 0, and it's gonna be an array. As you can see here, I put this one object inside of the array, because I want to match the return type of the function. And again, like I mentioned, you can return anything that you want here. It doesn't even have to be a user. You can return anything. The only thing that you have to understand is that once you do that, then it's not gonna spit out the error to the component. It's actually gonna just return this new observable and then pass it as the response. So let's go ahead and take a look at this in the code. So I'm back in the code, and we already have this function here where we are getting the list of all the users, and we already have the pipe operator imported here, and we're using it in this function. So we can just go inside of here and use the catch error. So I'm just gonna go here and do catch error. As you can see here, it's an operator. I'm gonna pass in the error, so that's gonna be the error. I'm just gonna call it error, give it a type of any. I don't know what type of error this is gonna return because I didn't build this API. And then what we want is multi-line. So I'm gonna do open and close curly braces and then go on a new line. And I need to do this. And then now what I want to return is any observable of anything. So here I can just do return an observable of. So to create an observable, you can just use the of clause. And then here I can just say empty array or something like that. So this is gonna just go and fetch this data from this URL. And then if there's an error, it's gonna default to this, which is gonna return an empty array. And here I could have just passed some user, like some object or something like that, but I don't necessarily have to do that. I can just return an empty array like this. So if I don't find any users, then I'm just gonna return an empty array. So now if we go back to the application, we can see that everything is working as expected because there were no errors. So let's go back and simulate an error. So let's go back to the app, and let's say I put multiple S's here, and let's go back. And if you look here, you can see that in our component, let me see if I can make this a little bit bigger. You can see that we have an empty array. Okay, so if we look at this line right here, if we expand this, you can see that this is line 39. And if we go into that line, you can see that the response is console logged here, which is an empty array. There's nothing in it. And then when we set this empty array to this user, then we get nothing, and that's why we have nothing here. So we didn't actually get an error. As opposed to if I didn't have this, right? So if I remove the pipe operator altogether, so if I go here and then just remove all of this, and the URL is still incorrect, and you can see that it's going to be different. You can see now we have this error. So let me refresh that. You see now we have this error that's printing on line 42. And if we check it, you can see line 42 right here is this error. So we actually got the error, and we could like handle this error here, or maybe show a pop-up to tell the user that there was an error or something like that. But the difference is if you do this, you actually don't send an error. You handle the error, and instead of sending an error, you send an empty array. And again, this can be any observable. You can create any kind of observable here and return it as long as it matches the type that this function is returning. And you know, you can just put a pipe here and then put a separate type, like for instance, string, right? Let's say this is gonna return a string, or you can put an observable of an empty array or something like that. You can see it doesn't complain. So just make sure that whatever you're returning here, it's not causing any problem with your return when the call is successful. So that's one way to handle errors, and then return some local data or some empty array or something like that. Here I'm just returning, well, technically it's local because I'm creating this empty array here on the fly. So it's local, like it lives on this application itself. I didn't fetch it from any API. So that's what I want you guys to understand. So you can catch the error and then return an observable of some sort. And this is catch and replace. Like we replace this error with something else. Now I'm gonna show you how we can do catch and rethrow. So the catch error is gonna work in a very similar way. So in our service, again, we're gonna have a function that's gonna try to retrieve some data, and then we're gonna use the pipe operator and then call the catch error again. But in this time, we're not gonna return an observable. We're gonna call the throw error function, and then we're gonna pass this error. Now we can manipulate this error as well before we pass it over to the throw error function. And what the throw error function is gonna do is it's just gonna emit this one error and then complete as an observable. So that means that in our component, we'll need to manage this in some way. So whenever we have our function that's calling the service to retrieve the data, the second function, so the error function is actually going to be called. But the advantage we have when we use the throw error is that we can manipulate this error in some way or check to see what's going on in that error, or maybe we might have to like change some of the message before we throw it out to the user and the component. So let's go ahead and take a look at this on the code, and I'm going to show you how you can put this together. So when we do catch and rethrow, we usually have a separate function that we call when there's an error like this, and then we pass the error to the function. And this function is going to take the error, maybe manipulate it in some way, change some things in it, and then spit that error back to the calling component. So here you can see that we're returning an empty array, but we don't want to do this. So when this error occurs, right, we get this error, we want to execute some piece of code here. So instead of returning an observable of empty, we're going to remove this. And let's say I'm going to create a function. I'm going to do this that handle errors, okay? And then pass it the error. I'm going to show you a different way we can do this. So now I have to create this function, quick fix declare method, and you can see that it's declared down here. So I'm going to remove it and put it at the bottom and just paste it at the very bottom here. And of course, this is going to only be used in this class. So I'm going to make this private and call it handle error. So when you handle the error, it's going to return an observable of never. So let's do observable and then pass in never here. So that's the first thing you need to understand, because it's never going to do anything. This observable is never going to like emit anything. We're just going to rethrow the error. There's no more observable. So that's why it's returning an observable of never. So now what we can do here is, instead of doing all of this work here, like assign the error in the function and then execute some code, we can actually just grab this entire thing and then just pass it in here like so. So we can go here, paste it in, and then we don't need all this code. Okay, so we can just do it like that. So we do pipe and then catch error, and then call this handle error. And you see that we don't do anything like this, like passing the error. It's gonna be passed automatically. So now what we can do is to just work on this function, because we know this function right here, it's gonna take the error, okay? The error is being passed in here as the parameter in this function. So now we can go down and then work on this function. So the first thing you have to understand is that this is gonna be of type HTTP error response, okay? It's always gonna be that. And then what we can do here is just throw the error again, because we're doing catch and rethrow. So we can just do return, and then we can call the throw error. So throw error, that's also coming from RxJS, and then we pass in the error. So we can just do that. It's almost like we didn't do anything. We're just gonna take the error from up here and then rethrow it from down here. So that doesn't do anything. But the advantage you have is you can manipulate this error. So for instance, I can say if the error dot something name or something like that. So I can just like look into this error. Let's say, hey, I'm checking the message. I look at the headers or whatever the case might be. Or I might just return like a string or something. Or I can look at the status and see if the status is like 404 or something like that, and then I can do some logic and then return something. So let's say if it's 404, we want to do something. So if it's 404, let's say we want to return some string, right? So instead of returning the error, we're going to say error 404 occurred, something like that. So now we're handling this error in some way and then manipulate it in some way. So I don't know if it's going to be a 404. So let's see if we can cause a 404 so that we can see this in action. So we have a wrong URL here. So let's check the browser to see if this is a 404. Okay, so it was a 404. As you can see here, it's a 404. So if I change this to, for instance, let's say 400. So let's go down. Let's say, hey, if it's 400, then do this. Then you will see that it won't be printed. So it just spit out the entire error to us, but we didn't see our message. But if we change this to 404, which is what this is going to return because we have the wrong URL here, then when we go back, you can see that the 404 error occurred. So the point is, when you catch and rethrow, you can manipulate the error. You can look inside of the error, like if you build your own API and you know what you're looking for, because the error itself, it can contain another object, and then inside of that object there can be useful information about the error itself, and then you can use that information to display something meaningful to the user, and maybe the user can take an action or something like that. But those are usually the two approaches that you usually see when handling errors when you're making HTTP requests in Angular. And again, you can do anything that you want here. You can check the status, you can return a string, you can actually return an object. So for instance, if it's 404, I can say return me an object, and I'm just giving you an example. You guys can think about whatever you want, and I can say code and then say 404, and then I can say message. What's the 404 message? So let's look it up real quick. 404 HTTP message. So the 404 is a not found. So let's say we want to say page not found or file not found. Okay, so let's say we want to say that as our custom error message. So then we can pass in this object. We can say, hey, this object now has a code, which is 404, and then we can pass in the message. We can just paste the message here, and that works just fine. You can see I got no errors or anything like that. So whenever there's a 404, instead of returning whatever error we were getting before coming from the API itself, then we're going to get this nice message. So now if we go back, you can see that we have the message right here. Okay, so that's how you can manipulate it. You can return whatever you want. And to be honest, that's what I do in most of my applications that I built, because whenever there's an error, I need to indicate that to the user that something wrong happened and they need to take certain action or refresh the page or log out or something like that. There are other cases where the catch and replace is more appropriate because you don't want to show an error. You might decide to show nothing to the user, or you can use some, local cache data or something like that. So it's going to come down to you and what you want to do in your application. And that's probably going to come down to the requirements of the application, what's more appropriate for you, or what approach is more appropriate for you to go for that specific application. Another important concept we need to understand when it comes to HTTP and Angular is the concept of HTTP interceptors. So you can see on the left, we have an Angular application, and that application is making HTTP requests. What you have to understand is that the interceptor sits in between the requests being made from the Angular application in the outside world or the internet. And you can see here that I have the interceptor in the middle, and the HTTP requests coming from the Angular application will go through the interceptor before they make it to the internet. And what that means is that you can intercept every request that's being made, and you can modify this request in any way or shape or form that you want. And you can already see how useful interceptors are in Angular. And it's usually used in security. So for instance, they can add some authorization token or some headers in the request before the request goes out. They can modify the body of the request before the request goes out. And whenever the HTTP response comes back, it will also go through the interceptors. And that's why we have the two errors here, one going out and one coming into the Angular application. So when you make a request, it goes through the interceptor, so you can manipulate that request in any way you want, and then send this request out to the internet. And when the response comes back, you can also look into that response, and you can modify that response before you give it back to the service, which ultimately will give it back to some component that's calling it. So the idea of interceptors, it's really pretty simple, but they're very useful, and they're used heavily in Angular to manage like security, HTTP errors, and a bunch of other use cases. So we're gonna go ahead and build an interceptor, and we're gonna implement some use cases of when you might want to use an interceptor. So you can use the CLI to generate the interceptor, or you can just create the file in the application manually. In my case, I'm gonna go ahead and use the Angular CLI because I like to use it. And you can see here, I have the documentation page open for the ng-generate interceptor command. And you can see here, you can just do ng-generate or ngg, and then you pass the key interceptor and then the name of the interceptor that you want to create. And you can see they have multiple different options down here that you can take a look if you're interested. So I'm gonna go ahead and just copy this command right here and then go back to the application in the terminal. I'm gonna stop it for now, and then I'm gonna paste the command. So I'm gonna go ahead and clear the screen and then paste it. So ng-generate interceptor, and I want to put the interceptor in an interceptor folder. So I'm gonna do interceptor and then /, let's say test interceptor. Okay, so we're just gonna put test, and then Angular CLI will do the rest for us. So I'm gonna click enter and let this go through. Okay, so you can see the file is created. So I'm gonna go back and run this again. So ng-serve, and then go back to the code and take a look. So you can see here we have this new folder that is created. It's called interceptor, and I'm gonna go ahead and just expand it. You can see here we have a test file, and then we have the test interceptor.ts. So I'm gonna go ahead and open this. So you can see the Angular CLI stubbed out the code for us. And then I'm going to show you how we can use this to actually intercept HTTP requests. The first thing I want to bring to your attention in this class is the injectable annotation here, which tells us that this class is a service, which means we have to hook it up in our main module. Again, interceptors are services. They're just, I guess, a special type of service. So we need to hook this interceptor in our module, or the main module where we want to use this interceptor. So let's go back into the app module, which is down here. And what we want to do, since it's a service, we have to provide it inside of the providers array. And to do this, we're going to pass an object. And the first property is going to be provide. And we're going to pass in HTTP interceptor in all caps. And then the second one is going to be use class. So we're going to tell it which class we're going to use. And this is going to be the test interceptor. And the last one we can pass is multi. So multi, and this is gonna tell the module if we're gonna have multiple interceptors. We're only gonna have one, so that's technically should be false, but I'm gonna set it to true for now, just in case we have more later. So this is how you hook this up, the interceptor up in the module. So now this is in this module, so whatever component belongs to this module, in this case the app component that we're using, then they will have access to this interceptor. So now let's go back to the interceptor. And just so you understand what's going on here, we're just implementing this interceptor class. And since we do that, then we have to define this intercept function that's coming from this class. And this function takes the request. So this is the request that we're making. And this is the handler that we have to pass the request to whenever we're done with the request, so that the request can continue its course. And another very important thing we need to understand about the request is that it's immutable. So this request here is immutable, which means that we can't change this object. We can actually make a clone of it and then change the clone and then pass the clone to the handler. And that's what we're going to do, because in itself, we cannot change this request because it's immutable. So let's say, for instance, we want to intercept every request, and then we want to pass in, let's say, some headers, or we want to modify the body or something like that. So how would we do this? So let's go ahead and let's say I'm going to define some API key here. So I'm going to say constant, say API token or something like that, and set this equal to some random string, right? So let's say this right here is my token. Okay, just some random string. Let's say this token is saved in the local storage, or we're gonna fetch it from some API using some of the logged in user information, whatever the case might be. The point is we have this token now. Now what we want to do is to make a clone of this request, because remember, we can't change this request directly as it is, as this object is right now, because it's immutable. So we have to make a clone of it. So I'm gonna do const, and then I'm gonna call the request. So request dot clone, and of course I need to set this equal to a variable. So let's say request copy, because it's a copy, and then set this equal to the clone. So this is the clone. And what we can do when we call the clone, we can also do whatever we want to do with that request there. So let's say we want to set some headers, then we will pass an object here, and then we can call set headers. As you can see, it's coming up here. And then we can just pass in our key. So we can say these headers, they're going to be an object. So we're gonna say open and close curly braces, and then here we're gonna say, let's say API token. Well, I want to give it the same name. So let's say API underscore key, for instance, and then set this equal to the key. So we're gonna say this is the API key or API token. So now we can just pass in this clone into the request handler. So we can just copy this clone and then paste it in here. So the clone will be passed into the request, and then this header will be added into that request. And another way we can do this is to pass in just the token, but it will give it the same name as the key and as the value. But if we want to give it a different key value pair, then we have to put the name and then the value. But if you could just do this like this, this will also still work. As you can see, we get no error. But the only difference is it's gonna be API token as the key of the header, and then this is gonna be the value. So let me put this back and I'm gonna show you the difference, but that's not really super important. Just thought I would tell you. So now if we run this application and check it in the request that's being made, we'll see that this token will be added. So let me double check. Okay, the application is running. So I'm gonna go back here and just clean this, expand this a little bit, go to the network tab where the HTTP requests are being made, and we probably need to fix this URL. So let me go back to the app, go to the service and remove the extra S's and go back. So now if we look, for instance, at any of these requests and expand this and scroll down here to the request headers, as you can see here, you can see at the bottom we have API key, and then we have the random string that I passed in. And again, if we just remove the name, so let's go back, remove the name here and just pass an API token, then it's just gonna have the same name. So you can see here, we can check any one of those, and you can see right here we have the API token, and then we have the token passed here. So we can do it the same way. If we want to give it a specific name that's different from this, then we can just put it the way that I had it earlier, which is just like that. So that's us modifying the headers, but you can also modify the body. So what I'm gonna do for more space is just put this on a new line. So if I go here and put a comma and then do control space, you can see all different things that I can access. So method, URL, set parameters, and a bunch of other things. And if I start typing body, you can see that I can change the body, as you can see here. So here, if I want to pass a body, I can put the body, and then let's say this is going to be an object. And here we can do something like, let's say hello, and then set this equal to a string, for instance. So let's say world, or some dummy example like that. So we're going to pass in the body, which is going to be a JSON object, and it's going to have a key of, or a property of hello with a value of world. So that's just a dummy example. I just want to show you that you can actually access the body and then modify that body as well. And we won't be able to see the request body in the browser because the browser is only showing the headers. So if you want to see what this request look like, we can actually just console log it. So I'm going to do console.log and then pass in the request copy. So request copy here, so that we can see what this request looks like as it goes out to the internet. So let's go back to the browser and let's just look at any of those requests. And or actually we need to go to the console, and you can see here in the test interceptor here that I have this request that I'm console logging, and we can take a look at it. You can see the body here has a hello and then world and everything else that's in the body already that we can actually access or modify in our clone. So you can change the body, you can add headers, and we can expand this header as well. And you can see that our API key is here, which is an array, and you can see the key is API key. The value is the dummy string that we passed in. Now, like I said before, interceptors are really useful, and they're heavily used in Angular, and you can use them to catch errors. As you can see here, it's a point where all requests are gonna go to. So what they would do is they would call the pipe operator on here. So they would just call the pipe operator and then do exactly what we did in the service here. So they would call the pipe operator and then do catch error and then do this piece of code here, which is just gonna run this error here. Well, this is just an example, but you would have your actual error handling function that's gonna take care of handling all your errors. Since this is a point of all the requests going in and out, then that would be a good place to handle errors. It's also a good use case for caching. So whenever you request data and the data comes back, then you can also use the pipe operator to tap into that data, or just look into it, or just make a copy and then save it to your local cache and things like that. So this is how you use interceptors, and you can have multiple different interceptors. So you can have one for authorization, one for caching, and one for handling errors, or you can do multiple things in one interceptor. So it's up to you on how you want to design the application. So I hope that was useful to you, and I will see you guys in the next video. So where do you go from here as a developer? So you just took this course and you pretty much understand how to use the HTTP client in Angular, and you can do some pretty cool stuff sending HTTP requests. Now, what do you do then? What I want to say is learning how to code, becoming a software developer or a full stack engineer or whatever you might call it, that takes a lot of learning and a lot of practice, because being a developer is a high level kind of skill. Like you need to really spend a lot of time to try to really understand all those abstract concepts and then be able to put them in practice. So the first thing that I would say is for you to really continue learning. So you really need to learn a lot. You have to read books, read blogs, take tutorials, take courses online or whatever you can find That's the first thing that I would definitely say that you have to do. You have to learn. There's a lot to learn, like a lot to learn. No kidding. So that's one thing. The second thing is to practice. So if you don't practice it, because it's so high level knowledge and it's very abstract, you really have to practice it in order to remember it and memorize it and fully understand it and put it in practice. So you really have to practice it, build the application. After you learn something, you have to put it in practice. Otherwise, you're going to forget it. And the next thing you have to do is, again, practice. I know I'm saying this twice, but it's really to put emphasis on this. You really have to practice what you learn. Otherwise, you're going to forget it. So this course was not very long, but there's a lot that I covered, and there's a lot of things that I just barely scratched the surface on them. So you will never really build an application in the real world where everything is so smooth and you have no errors. There's no crazy requirement from your customers or anything like that. So it's never going to be that smooth, but at least you have a foundation where you can start building upon, and then sharpen your skills and all of that. So you have to practice a lot. You learn, and then after you learn, you think you understand the concept. Don't spend too much time learning. Like, don't read a whole 3,000 page book or anything like that. That's definitely not the best use of your time. But if you learn a concept, you think you understand it, and think about a real world scenario where you can apply that knowledge, then you have to take that knowledge and then put it into practice. So you have to practice a lot. That's the only way you're going to really remember all those things that we just learned. And you can also try to build real world applications. So you can take, let's say, you can even take any application like Facebook, Instagram, and you can build a small version of it. I mean, you don't really have to implement every single feature, because those applications, they have tons of resources and they've matured because they've been around for many years now. So it's really gonna be too much for you to try to build, let's say, Facebook. There's just too many features. But you can actually build small features together and then put something in practice. And you'll be amazed how much you will learn just by trying to build some real world application, and you want things to work the way that you want. So learn, and then practice, build applications, practice some more.